tonight, I am your guest speaker. In case you don't know me, I am G. Truglia or Jerry or Shithead, whatever you want to call me, it doesn't matter. But we're going to be talking about Misfire Diagnosis. And what will be covered? Where to start your diagnostic game plan. This is important. And this presentation is going to have a lot of different things sprinkled through. Some you know, some you don't know, some you're rusty on, and some you're going to go, how come I'm not doing that? Okay? So it's really to engage you and think about it. When I developed this class, it was for a state program. And because misfire codes are still some of the top 10 codes out there, it's still a problem. And when we think of misfire, we think of misfire as ignition is probably the #1 thing that people pop up with. But it could be fuel. It could be an emission-related device like EGR. It could be mechanical, and that's usually overlooked. Okay, so we're going to show you some things here. So the basics of misfire, what's needed to run an engine. That's super important. Relative compression. If you're not doing relative compression, you're selling yourself short. And we're going to talk about that. It's simple to do, and it's something that's good. Cranking compression and cylinder leak down, well, you do them, but they're very labor intensive, aren't they? And the customer doesn't really want to pay. When guys like yourself, or sometimes even a regular customer brings a car in, they're usually a bunch of tightwads. You know, they don't want to spend a lot of money. Let's face it, when a car comes in with some sort of bad problem, this thing has about 100,000+ miles on it, right? And it's always like, oh, it's only going to be a station car, we're going to get rid of it. Well, we know that story. So, right, and you still see it years later, the car's still there. So we need to make sure that we could diagnose this car quickly and effectively. Vacuum and back pressure testing. Some basic stuff that you've done for years. And in the beginning, we're going to start out very slowly with some basic stuff, get into some advanced stuff. Pressure transducers and special misfire detectors. Now these could come in real handy. We had a couple of guys in the class last night that had, you know, issues with a V-type motor like an Audi. And when you got a dual timing chain on an Audi and you have a problem, do you want to spend about 10+ hours pulling something apart? Or do we just want to take a spark plug out and put a pressure transducer in it and tell the guy, hey, you got a problem? And you can verify that problem. So that's what some of the things that are out there, as well as a pressure transducer in a tailpipe. And something that you can make for about $40 or so. Just by going to Radio Shack, you can make a vacuum pressure transducer. And Rich can get you a good GM map sensor, or you could buy it from General Motors themselves. And all you need is a 9-volt battery and a 9-volt to 5-volt transducer. And guess what? You got yourself a damn good vacuum transducer, and we'll show you how you can use that for running vacuum as well as cranking vacuum. You can see if you have an engine problem. Primary and secondary ignition testing and fuel testing, and case studies sprinkled throughout. Now, at any time as I'm going through this, if you have a question, there's no such thing as a stupid question, only one you don't ask. So please feel free to ask any question. Everyone here knows something that the other guy doesn't know. And if you remember a while back, an article that not only I put in Motor Age, we did a webcast, I think I even did something here on it at one point. There was one guy in my class up in Massachusetts where he was in a week-long class, hands-on class with me, and he was annoying everyone because this guy was Mr. Question Man. Ooh, how about this? What's that? And they were kind of looking at him, and we're our own worst enemy, right? You know, to go, oh, this guy, another question? To the point where they were telling him, would you shut up? Well, he finally came up with a good thing. You know the breakout box? And you're going to see a picture of this. That breakout box being right in the diagnostic link connector, hooking your lab scope up, in less than 2 minutes without opening the hood on a car, you got relative compression. Why aren't you doing it? Okay? And we're going to show you that OEs are really into making sure that mechanically this vehicle is in good shape. Okay? So very, very important. So when a vehicle comes in with that mill illuminated, and you can see this thing got 200 and something thousand miles on it, okay? When that comes in, where's the right place to start? Now, huh?
Read the codes.
Read the codes. But even before that, what do you want to do? You want to read the customer. When did this thing start? Okay, you do want to test drive it, and I thought those are wrong. Okay, but you want to ask the customer certain questions. A lot of times, the idiot could have put diesel in there. He could have ran low on fuel, right? Something could have happened. He could have ran over something. Who knows, right? He could have put plugs in there. You know, some of these people, they read that magazine and they buy Spitfire or some crap, put them in there. You ever come across problems like that? It'll drive you nuts and go, oh, the guy put new plugs in, so I'm not going to check them. You can't take anything for granted working on a car, okay, or a vehicle, I should say. So where do you start your game plan? You got to start with the basics. And I want to remind you, if you go back to the big box scope, and there's enough of us old guys in here that had the Bear, the Sun, the Allen, the Marquettes, you always started with the battery up, right? And you checked the emission gases. How many guys still have a gas analyzer? You really should, because it can really save your ass a lot of time, hell of a lot of time, okay? So, you know, the old days of looking at stuff, well, you know, if you got black smoke like this car is really in bad shape, running super duper duper rich. In fact, we had a situation like that today. Right after I sprained my ankle, my brain wasn't working too good. We had a BMW in there, and the guys cranked the vehicle. We had done a transmission on it, but they were cranking this when the battery was really weak. You know, it was outside, someone left the dome light on like an idiot, they didn't charge it up. You crank it. Now you go, well, it cranks over, it must be good enough to start. The problem is, you're going to dump fuel and not have enough spark, right? So Mr. Pierre's a walking BMW. Called them up, and it sounded like it did lose compression. He goes, oh yeah, that's common. Some other TST member had called me up recently. You know, just put some motor oil on it. Well, this thing had such washdown that you would have swore that the timing belt, or chain in this case, was broken. Okay, because it was just, it's like nothing. Took the plugs out, the oil didn't work. It's always good to have some STP around. Put some STP in there, dried the plugs out, took the fuel pump relays out to crank it over a little bit, to put the battery charger on it for a while, starts up, but the smoke that came out, oh my God. And as in the shop, of course, you had to open all the doors up, put the fans on, the whole bit. You normally don't see a car running that rich, but if you did, you know you're looking for a fuel problem, right? Okay. If you see oil burning, okay, you've seen this a lot on different cars, like those Mitsubishis with oil seal problems and stuff, right? They're out there. And if you see white smoke, none of these conditions are you going to start dumping parts at the car. You got to find all the basic problems first, right? When you look at misfire stuff, you look at this P0300, sometimes this can throw people off. It's a random misfire. A random misfire could be multiple things, correct? Now, it's not telling you a specific cylinder, but there's a few things that you should be looking at in case you're not. You want to see freeze frame. Freeze frame is a stamp of when it happened. Well, looking at this, we could see the load. We could see the short-term fuel trim minus 24, so something's going on right now. Long terms are not that bad, but right now something's going on bank 2. What's the other thing you want to look at on this screen? Well, one of the big things, this is an emission state, New Jersey. We want to look at the monitor status. If all the monitors are not ready, and you fix this person's misfire, and let's say, which is common, the Evap code is not, the Evap monitor is not ready. Do you know what's going to happen? Those people are going to come back to you and say, hey, the check engine light's on, okay, and you didn't fix my car right. Do you think they know the difference for that check engine light being on for a misfire code of that? And this is why when you use a PC-based type thing, or even if you use a hard tool like a Snap-on or an OTC, we all have cameras on our phones, correct? Take pictures, because that's going to be your documentation. And we print out tons of pictures. I give them a whole full color screen, just like you would see here. Comes out in color. I don't worry about the ink, because you know what? If you're charging the right amount, you should be able to afford all that. When you give it to them and you explain to them what's going on, they're not going to come back and break your chops 5 o'clock on a Saturday when you want to get out of there, or on a Friday night, or whatever the case may be, right? Different scan tools give you some other different information. Like right here, that hexadecimal 10, that's telling you on this Autel tool, you're in the engine controller. Okay? If it said 18, you would be in the tranny controller. That's a non-CAN vehicle. You get something like AutoLogic, which is on European cars. This is a Mercedes-Benz. You could get factory type of codes like a 0632 or a P0632 that sometimes you won't find on your information system. Lucky that this one tells you, in plain English, you got a 300 and a 303, and you also have a thermostat type problem, a P0128. Okay? So you need an arsenal of tools in your shop. You can't work with one scan tool anymore. That's becoming more and more difficult to do it. You can see here on another car, we have a problem with cylinder number 1, number 6, and several misfires. Now, always go when you got a specific cylinder, you can easily start there. Sometimes, depending what the engine configuration is, those cylinders may be causing the random misfire because we got uneven pulses, right? When you look at random misfire, how do you think they come up with this particular code? From the crank sensor, correct? And this is all algorithm that's programmed into the computer. So anything, you could even have a transmission problem. You could have a drive shaft binding up or a CV axle, and I've come across this. If it's binding up mechanically, that can give you a misfire. Okay? Anything that slows up the crankshaft from its normal speed can give you an issue. Now, they may not be as common, but it's something for you to think about, correct? When you have misfire graphs like this one sticks right out at you. You don't need the Tech 2. This is the GM scan tool. You don't need this. You could do this on Snap-on or OTC or some of the other scan tools. You want to look at things graphically because it's easier to pick up. You want to go into a misfire graph because that's all the scan tool is looking at. I bet each and every one of you has had problems when you've had your scan tool looking at a whole bunch of parameters, you race the motor up, and you happen to be catching the RPM, and see the RPM doesn't change for a few seconds, and then it changes. That's because all that information is going in and doing this down the list. Okay? That's why one of the reasons they tell you pick PIDs, or while I'm on the GM tool, engine 1, engine 2, EGR, Evap. Why do you think they have these all separated? And when you're using a tool like we just looked at before, AutoLogic, you go into the DME or one of the engine modules on different European cars, it's all broken in sections. They don't give you a whole array of stuff. They want you to look at all little compartments. Why? Because they know that the data will not come out fast enough to your scan tool. Okay? So you got to be aware of that. Now, here's a good one. We have a O2 sensor problem, bank 1 sensor 1, P0135, a 301, a 302, 303, 304, and random. And the 303 is the freeze frame that tells us we got a negative 6.25 and the vehicle wasn't even moving. We look at speed. Monitors are all set. Where do we start? What is going to cause all those cylinders for a misfire? Plus the random. You think it's spark plugs will fix it? All new coils or wires? Probably not. Has to be something in common with all the cylinders.
Plug cap.
Huh?
Plug cap.
Maybe a plug cat? Maybe. What else do you think it could be?
Fuel mixture.
Could be fuel, right? Could be a fuel-related problem, okay? So it's something I just want you to think out of the box. Now, I want to show you, this is off the Ford HDS, the factory scan tool. When you go into Ford and it gives you any codes, you notice here I clicked on cylinder misfire number 1. I could have done number 3 or whatever, but I did number 1. In case you don't know, this is like their diagnostic plan. Rather than going to look at the manual, they built it into the tool. Notice it says they have their own number, a 71-1 equals a P0301, okay? Cylinder misfire 1, possible faults. 1 cylinder misfire, fuel or mechanical. fuel injector clogged or leaking, fuel injector harness open or shorted, compression low, valve clearance incorrect. These are just some of the things. How many of you guys have checked valves or adjusted valves recently? Nah, probably not. And a lot of times on a P0420, the fixes, especially if it has adjustable valves on the car, they haven't been adjusted. You know, one of the things to look at. Electrically, spark plug, carbon deposits or fouling, an open wire or leaking current, ignition coil problem, a computer type problem, distributor failure if it has it, fuel pump pressure, and the fuel line is clogged. So those are all the things they're telling you that could possibly cause a misfire. Does that make sense? So in case you don't think of that, and a lot of people really just don't think of it. It's not in your game plan. Try to put this stuff in your game plan. Now, the other thing you need to know is enabling criteria or code setting criteria. And in this case, how in the world did it set this code? What do you need to set it? This happens to be an example from Toyota Motor Company. You'll notice it says, while idling or driving, not during deceleration. So it can't do it at those times. Okay? The temperature has to be, coolant temp has to be greater than 14 degrees Fahrenheit. Air temperature, they don't worry about. Battery has to be greater than 11. Speed, you need 3,000 RPMs and so on. So when you're looking at a tough car where you've done all your basic preliminary checks and you're not sure going, I don't know, I put wires in, I put coils in, well, it ain't working. You should have read up on what is needed to set that code. Because there's no real secret. That criteria is programmed into the computer. Like how many of you guys have made a misfire at idle, but it doesn't set a code? Sets no code whatsoever. You know why? Because the criteria is the Prindle has to be in gear, it needs to see VSS, vehicle speed, and it needs to see some load or it ain't going to put the light on. Now you go back to the early days of OBD2, or the light came on all the time. Well, that hurts companies when the light comes on all the time, right? And some companies intentionally program things so lights would not come on until the federal government nailed their pants and they had to wind up paying for it, okay? We can also use mode 6, and very friendly on a Ford, we get misfire updates. And in this case here, we got cylinder number 1, the max is 0.983. We're popping out a 3.226, way over the limit. And this particular scan tool, this is the E-scan, but same with Auto Ingenuity, they color it red to warn you, hey, there's a problem there, in case your eyeballs don't see it, okay? We also have the cylinder events, multiple events, that's like your random misfire, and the highest emission threshold levels both failed along with it, okay? So mode 6 could be another tool that makes it quite helpful to look at. When you look at this particular car, this is a 4-cylinder, and one of the things I want to warn you when I talk about mode 6 real quick is, well, you got 2.6505 for the limit. You're only at 03.10, but you know what winded up happening to this? This was a new set of wires from a parts store, aftermarket parts, a name that you would know. I'm not going to mention the name. But after a while, that very thing right there caused a misfire. And it caused the light to come on. Now, what you should be aware of is non-CAN Ford cars, non-control area network cars. They just put all the cylinders. And you notice how these are all failures? It doesn't have cylinder 5, 6, 7, and 8, so you got to be careful. It could be the same thing with EGR or air pump. The car doesn't have it on there, but what happened? This manufacturer just goes, let's use the whole template of everything we have, and if it's not there, it's going to fail. You got to make sure if it's there or not. You need to look underneath the hood. By law, it's supposed to have a sticker. And that sticker says it complies with OBD2 standards, and it has a PCV or EGR or Evap system. You've all seen the stickers, right? Of course, when it goes to a body shop, sometimes some people don't put the stickers back on. Makes life a little difficult, correct? And using mode 6 again here, we can see right away if we fail something, even if the light is not on, this is going like this to you. Wake up, this dude's going to have this problem. This is a good predictor of what the problem could be. This was off my Hemi years back. I took this shot, and I had an issue where this thing would roll every once in a while. Now look at the maximum, 65 plus thousand, right? I'm only at 44. I switched this thing around a couple of times, and it probably would get worse because I would feel it sometimes you wouldn't feel it. It happened to be a bad plug, so all I had to do was replace one plug in it. And the car really, I think it happened at about 9,000 miles or so. It wasn't even a lot of mileage on it. So I just got a new plug and threw it in. You know, you bring something sometimes to the dealer, yeah, you got no problem. No codes, no problem. And notice it didn't fail mode 6, but I started having count-ups. And that's important. So mode 6 could be your friend sometimes. Graphing. Here's the OTC Genesis. Now you can do this on a Snap-on or an Autel or any other tool that's out there, Autoland, Scientech, anything that graphs, you can utilize it. Launch. It's good to see what cylinder's doing it, and you can play all of these events back, which is kind of nice. Okay? Now, here's the Ford IDS. This is the Ford factory tool. On this thing, you could see it's a misfire monitor. You see the little blue lines here, and you got the dark blue line, but you see all the little light blues? That's showing you every time it misfired. The bar goes up and down. That's the way they graph it out for you to look at. So you got some misfires going on. Are there any that are super duper bad? Not really, because they have little threshold levels. If they get too high or too low, then you know you got an issue. And if you look at the power balance, you remember power balance on the old machines, right? You punch a cylinder out, hey, I didn't hear the RPM change or didn't see it change. We got an issue going on. Could be bad ignition, it could be bad fuel, could be mechanical problem, right? So power balance in this case, you don't have to be a rocket scientist to see that cylinder number 6 at the end is an issue, correct? And this is all off the Ford factory tool. So different scan tool readings that I gave you there, and you'll see a whole bunch more sprinkled through, are going to be something that you need to look at and get used to the tools you're using. Now, having a lot of different scan tools, I pick certain tools on certain cars, in all honesty, because I know some are going to work better. Now, every once in a while, I'm not going to mention the brand, I pick something up and go, oh, let's see if they improved it. And a lot of these things now, in your shop, they're online and they do automatic updates. Go on it, and if it's still bad, you know, I give them like 3 strikes and you're out, and then I don't use the tool for quite some time. You know, like if I'm working on a Nissan, I want to pick up the Autoland Scientech iScan WT. I mean, that thing is like having the factory tool, but it's a lot easier. It works good on a lot of different cars. You know, some cars that you're having an issue with, you pick an Autel up or a Launch, man, you're home free. And other cars, you pick the Snap-on up, it does a good job. You put it on other cars, doesn't. Same with OTC. So you need to know where and when, what to use. Factory tools, when I pull any of them out, you know, whether it's programming a key or doing programming on a vehicle, that's a different ballgame. But for quick stuff, because money, you're getting paid by the hour. And we need to be able to diagnose this thing quickly. And here's what brings me to diagnosing it quickly. Now, you got 3 failing gases here. But I ain't worried about the 3 failing gases. The failing gas is a CO from a rich mixture. NOx, which you're not going to get in your shop anyway, or a very low amount, has to be on the load unless you got a dyno. And HC, hydrocarbons. You have a good catalytic converter in most cases on a car that's going to mask that problem. My job here is to tell you how we're going to find a misfire. Well, 2 of the other gases are super good, and all you did was throw the probe in the tailpipe. In this room, we are breathing 19 to 21% oxygen. So if you had a gas bench and you put it on, it's going to tell you 19 to 21% is what we're breathing in oxygen. Okay? Now that's an important fact. That's what's going in your motor, unless you have some sort of restriction, correct? Well, when I put this thing in the tailpipe, what's a good reading that should be coming out the end of the tailpipe? About 0.5%. You know why? All of the oxygen, you've probably seen the movie Backdraft, right? How does a fire work? How does your torch work, right? You ever get the guy that puts the torch on and the black stuff's all over? Dude, get the oxygen, will you? You get all this black crap all over the place. Oxygen makes it hotter, right? That's what helps a fire. So what you need is to use that oxygen up. The engine uses a lot of the oxygen up, and then we don't have catalytic converters anymore on most of the new cars for years now that have air pumps going down to them, right? Only air upstream. Nothing goes to the catalytic converter for years. So the rest of the oxygen that's not used in the engine gets stored in the catalytic converter, correct? And what do you think it does there? It helps break everything down. It has to get used up. Very little should come out the tailpipe. So if I put a probe in the tailpipe right away and I see 1% coming out the back, you got a misfire, dude. I see 3%, 5%, you got a bad problem. Now the other barometer is CO2, combustion efficiency. Now on all of the vehicles you're working on nowadays, a good running motor should have 14%, maybe up to 17% CO2. They are working on another converter to break down CO2 because you've all heard about CO2 greenhouse effect. I'm not saying I believe in it or whatever, but guess what? This thing right now tells us good efficiency. So if I got a number under 14, I got some sort of problem. This motor is not working the way it used to work. Also a gas analyzer, if you do Evap stuff, it comes in quite handy. How many times you don't see smoke coming out? If you're working on some of these cars, and a smoke machine's a great tool. But I'm working on a Nissan or Toyota vehicle, and there's a canister problem, which is somewhat common on them. Well, what happens to the smoke? You don't see it come out of the canister. You know why? The charcoal's eating it up. I just had one on a Hyundai. I couldn't find smoke coming out. The ball is up right above 20 thousandths because it was a 20 thousandths leak is why the light came off. It was about maybe 28,000. I'm looking for smoke, and always baseline the machine. Smoke's coming out like mad. I put it in there. I can't find smoke anywhere. I take the rear seat out. I take the little inspection cover off because there's the fuel pump. I'm looking. I don't see any smoke at all. I take my gas analyzer because I flow CO2. You shouldn't flow air. Either nitrogen or CO2 is what you should be using. Putting air with hydrocarbon fumes, and then you're using your scan tool to put a solenoid on and off for a power probe, well, that can create a spark, right? And air, you got yourself a fire, correct? So use a non-inert gas, less chance of a fire. And that's what every manufacturer recommends, either nitrogen or CO2. So I don't have a nitrogen tester, but I got a CO2 tester, right? And I see this thing really giving me a high reading. Now, you probably know about the Bernie tool. He has that bullseye thing. So that's a little gas bench in itself for CO2. I take it out, and this thing's like beep, 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 beep. It's going crazy, just like my gas bench. I take his crazy foam, I spray it. Holy crap, the stuff turns yellow. I know we got a leak there. Now, this is a composite tank, so you can't say the tank rotted. The ring is metal, and by the way, if you've ever taken one of these off, because there's a fuel filter in there, nowadays it's not the hammer and the punch. You need the special sockets for this. I take this thing off, we get a new locking ring, which I always do anyway, and a new O-ring, job fixed. Not going to do it without a gas bench or without that tool, okay? So think about what you can do, and even when someone says, I smell fumes in the car, you put the frickin' tool in the car. I mean, a lot of these gas benches, like if you own a Genesis, I have two of those little things. I take them on the road when I'm doing classes because all I got to do is carry this one thing and I got a gas bench with me. Or you can be like that guy last year who won the $5,800 machine, the gas analyzer at the big event. That one's pretty nice. It's pretty small. Put it in the car, runs on battery power. If you plug it into the wall for a while, it stays lit. You can see a whole bunch of problems with a gas bench. Very good for misfire. And real quick when you look at a car, Lambda. Lambda is air-fuel ratio. When we look at the number 1 of Lambda, the car is running about perfect, or 0.97 to be precise. Anything higher than the 0.97 or 1 to make life easier, you're not running rich, you're running lean. Okay? Now that's a quick calculation. Most people hate when I speak about gas bench stuff. They go, you know, when I was teaching in Hawaii stuff, they have no emission program. Down in Florida, no emission program. We don't need that crap. Yes, you do. It's a diagnostic tool that works quite well. But you know what the problem is? We buy a lot of tools, we don't use them effectively. They sit there to collect dust because I don't really need that. You can quickly diagnose stuff. Pierre still uses a gas bench. Okay, I use a gas bench. I have 5 gas benches. But of course, it's a lot easier when you don't have to buy them. Okay, but even in the days when I had to buy them, I always bought a gas bench. Every one of my shops had gas benches in them. Not just for emission testing, because we had a special emission machine for that, but for diagnostic purposes. So everything starts here with suck, squeeze, bang, and blow, or intake, compression, power, and exhaust. If we have a problem here, everything else is going to be a non-issue. What do I mean by that? You get a mass airflow sensor problem, but you got a mechanical problem. Why are you going to throw the mass airflow sensor at the car? Ain't going to fix the problem, or the O2 sensor, or air fuel, or any other thing. We need to start right here. You need to know if you got air. Is air getting into the motor? You're breathing, but is the engine breathing? Which brings you back to some basic stuff we're going to go over first. Is air really getting in that motor? You know, the old days of looking down the carburetor, you could say, well, we got fuel, like that fuel tank there. How do you know you're getting fuel right now? Okay. Especially if you don't have a gas bench, you're going to be working a lot harder to figure that one out. And do we have spark? One of the things, and you'll see a picture of it as we're going through, I just used it today. That little box that we were selling through TST, it's made in Canada, the Coil unplugged tester or something, has a red box with a yellow wand on it. Thing is phenomenal. It tells you burn time, spark KV. In seconds, you know if you got an issue. Okay? Works real well. So, which brings me to this. You got to start a 5-minute test. First thing, because I'm lazy, I'm going to take the power booster hose. I'm going to take my old snap-on gauge here, and I'm going to plug this into the power booster hose, and I'm going to see if that needle is bouncing about 3 to 5 inches, which is telling me I don't have a broken timing chain or belt, right? The valves are doing something, opening and closing. I got air going in. At the same time, when I'm done with that, before I put the hose back with the clamp, I'm going to run some propane. And many of you guys have maybe an old carburetor set up where you used to set carburetors up with a flow meter or whatever, or you could buy just a little piece that goes on here that comes off with like a little brake line almost on it where you can flow propane. Now, to start a motor up that has no fuel per se, you want to flow that little propane bottle, and I like using the Coleman ones. They got plastic on the bottom, they don't scratch the paint. They're a little fatter rather than the thin bottles. I'll flow it for about a minute or two, then go in, and if the motor gives me the dance, it starts to kick now, and a lot of times it'll start depending on the motor. Guess what? I got a fuel problem. If I don't have that, well, there's my gas analyzer. I put the probe in the tailpipe, crank it over. If I get 185, that's not good. If I get about 2,500 or more hydrocarbons, parts per million, I got gas. What am I looking for? Now it brings me to spark, and here's another issue. Like some of the guys last night saying, well, I have the little spark plug tester. You know, the one that has no electrode on it. Not good enough for most of the cars you're working on. You're on a coil on plug car. This is not a coil on plug, this is a coil and well, but it's at 45 thousandths. If I'm on a coil on plug, I need to screw this thing all the way out, which will give you 80 thousandths of a gap. If you could fire that, now you know you got good spark. The problem is, people think with the wrong tester I got good spark. You know, like Noid lights, right? Oh, the Noid light, you put it on an injector, you blink, oh yeah, it's good. I'm going to show you later that that's not good. because that's only a couple of hundred, 200 to 300 milliamps. That's not enough to open an injector. Same thing with testing a module. I'm going to show you how to do that later. And General Motors gave you a test right from GM that said to use your test light. That's another 200 to 300 milliamps. How much does a coil put out? We'll be speaking about that. Coil puts a lot more out. So these are things you need to say. Now, if I have no spark, the scan tool is great because on 95% or more, if I have no spark, I'm going to look at RPM, which would tell me no RPM, crank sensor problem, right? And I just did this recently on a Mercedes-Benz, a 2007 Mercedes-Benz. The guy's car was cutting out when it got hot. I'm not going to bust my noodles. I crank it over, I look at the scan tool. As soon as the car got hot, RPMs die and you get no RPMs. Put the labscope on a crank sensor, which was a pain in the butt, buried all the way in the back. You know, you got to do one of those dumpster dives in it, right? And you get on it, confirm it, and by the way, those wires are a little hard to back probe. So I use that Hickman or Hickman probe, you know, the one that thing is like so small you can't see it. It doesn't break a wire, and you should get them. Fluke makes the best ones. This needle is so small, it's very difficult to see, and it just barely goes through the insulation. Does not break strands, because I've done a lot of testing with it. Put it there, then I have liquid tape in my box. I clean the wire off. Even though it says it goes back, I don't trust it. But I could not get in to back probe it because it's a tight spot and the connectors are real tight on Mercedes. So right away, as soon as it got hot, boom, boom, dead. Get a new crank sensor. The dude's on his way. Okay? And back pressure testing. Can't get 5 pounds of dew out of a 1 pound bag. Perhaps you worked with someone and you wanted to play a joke on him and you took a potato or something and banged it up his tailpipe. And if he had a good exhaust system, he wasn't going anywhere, was he? Okay? Well, back pressure is very important to check. And if we had a car that had too much back pressure at idle, and you didn't want to unscrew the air-fuel ratio sensor, or you didn't want to take the EGR valve out, what's the quickest way to get this car in your shop? Take a spark plug out. Take the spark plug out because you were leaving 5 pounds of pressure out of a 1 pound bag. Now, make sure you disable ignition on that cylinder, otherwise we'll get a flash back to NOM, won't be good, right? You'll get a flamethrower. We need to disable fuel and spark. Those are two things, and when you let that plug out, you're going to see that this motor is going to start up. It ain't going to run great, but I don't have to push from here to there. I'm a happy camper. Correct? So these are little things that I want you to check for. Also, you can see the little Techron thing here, or the old dollar bill test. Well, it's not supposed to suck, it's supposed to blow. Now, you may be praying for something like that tonight, but guess what? I have had vehicles that have come in. I remember one Porsche. Now, you know, your brain, your eyes, your ears, your nose, your hands are the most important tools you have. This came from another shop. I seen a new starter in there. I did that test, and I'm not BSing you. It sucked it. The starter was spinning the wrong way. And we had that recently where one of the parts stores sent us a starter. They put it in. It cranked, because the old one didn't crank. It cranked, but this thing wasn't starting. It didn't sound right. Put the dollar bill at the back or a piece of cardboard, it's sucking it in. The starter was wound the wrong way. Because a lot of cars, they may start clockwise or counterclockwise. You have to know which one. And you know these production lines, right? Some guy, I don't care. Is he ever going to have interaction with any of us? Hell no. He's some guy working in some sweatshop somewhere, some factory. Okay? So be careful. Don't take things for granted going, oh yeah, that's the way the engine's supposed to spin. Make sure it's the correct way. Yes, Al?
On that last screen, when you
I'll go back.
about
This?
good back pressure,
Yes.
you disable the cylinder, spark and fuel.
Yep.
And you put a vacuum gauge in there?
No, just take the spark plug out. You'll drive the vehicle right in.
I'm sorry?
Just take the spark plug right out and you'll be able to drive it in.
And that'll allow you to
Yeah.
relieve the back pressure.
When you check for back pressure, you could go into an oxygen sensor hole, wherever you want to go. By the way, I'm not a big one of putting holes in pipes. Because these pipes are expensive, stainless steel pipes. There's all these kits that you do these. My state, by the way, it's against the law in New York State to do that. It's like a tampering thing, and you know, some guys, we'll weld it up, or I don't do that. You know, if you want to do it, it's up to you. Relative compression on a generic scan tool. This is the OTC. This is the OTC Genesis on a Ford, giving us relative compression, and this engine is damn good. And by the way, you know how long it takes you? Not long at all. You plug the tool in, you went in, you're done in minutes. Minutes. Here's Ford. Right away on this one, the IDS, I love it, toolbox is right up on your list. You pull this down and you'll see some menus. This is a quick, easy test to do. Now, 3 OE companies have put this in their tools. General Motors has added that now on the new MDI. Ford has it in there, and Toyota, and probably more companies are going to do it. The reason why they put in relative compression is, let's be honest, their own guys in their dealerships are misdiagnosing stuff. They're throwing parts at a vehicle, and there's nothing worse when you sold this guy mass airflow sensor or tune-up, and I get cars in, so I can tell you that people have thrown these parts at it and go, you got a mechanical problem. Well, why didn't the guy tell me that? Well, it's a whole other ballgame. I don't get involved in that. You know, the guy's going to have to go back to whoever did it, and you got yourself a nasty customer. Now, obviously, the older we get a little smarter and wiser and go, I got bit last time. But you need that diagnostic game plan. You shouldn't be going back, guessing, going, okay, this one's going to be okay, that one's not. Do the same thing all the time. It's like when you go to the doctor. He has that little clipboard. He's going to follow, checking your heartbeat, your blood pressure, right? Your temperature. We need to do the same thing in our business. It's too fragmented, our business, because you may have started out working at one type of dealership or a tire store or an independent shop. So we all do things differently. And then when we come out to seminars or hands-on classes, you may take something that interests you, not something necessarily that builds your skill level the right way. Starting out with something very low end and going up to high end. A lot of people miss the basics. And we could tell you that even when we did those tests, we had over a 50% failure rate with people using the meter. And a lot of the guys were ASE certified, master ASE certified. But we had people put it on AC voltage, trying to test a DC circuit. We had people use ohm meter, checking a live circuit. You know, we had people in the amp jack. No lie. I mean, these guys can tell you because they were there as well.
Wire boys. We have wire boys.
We had guys that had multiple problems, okay? That's all because no one's ever stupid. You just don't know what you don't know, and then take the time to learn. So you need to do that. So here we could see right away the firing order. By the way, you're just plugging this into the diagnostic link connector. You're picking toolbox, and when you got something with a 38% or so loss here, you got a problem. You got a bad problem, okay? Now, this is the Toyota screen, and you're going, well, there's not that pretty picture like this with bars. Here's how they do theirs. You see all the RPMs? 202, 203, 200, 203, 202, 201, 201. The lines are all different colors from blue, green, whatever. They're all superimposed here. If we had an issue, the line would be out of sync. In other words, you'd see one up, one down, whatever the case may be. So they're checking things right away. Why? They don't want to throw, or do you want to take those rear plugs out of the 6-cylinder or 8-cylinder one? You got to remove a whole manifold? Okay? Now, we did that recently. We had a couple of them come in with low mileage on these Toyotas V6 motors where the guy had a couple of bad coils in the back. But before you do that and sell this guy an intake plenum gasket, the whole 9 yards, and all this labor, you want to run this test and see if you got a problem. Okay? And it's easy to do. Just buy the scan tool. The old Fluke 98. I still use this. You can probably get these on eBay relatively cheap. Okay? In its day, it was about a $3,800 tool. If you're going to buy one, try to look for Series 2. Excuse me. Series 2 will give you the white screen and give you this nice bar graph. Otherwise, you're going to see a couple of screens I'm going to show you that don't have bar graph, but you can still do it. And right away, you can tell someone, oh boy, we're about 12% here, you're going to start seeing a problem in the cylinder. Okay? I had one on a Mazda come in on a V6 motor that people were told from another shop that they needed a catalytic converter, which they did have a P0420. I look at it, I wasn't going to throw a converter in this car. You know why? When I did relative compression on it, it had an engine problem. It's not going to fix your problem. And then you throw a converter at it, you're talking some nice money, right? Okay? And in our state, we have to use a COB certified catalytic converter. We're not allowed to use some cheapie that's this little thing. It has to be either the OEM one or a COB certified one, which is going to cost you big money anyway, which is a direct fit with the right amount of material in it. So this is off any other scope, but this happens to be a fluke scope. And what you see up top is a peak and valley type of setup. Don't worry about the hash. We're on AC voltage. You know how you can tell? There's 0. We're above and below. This will take you 2 minutes or less to do. All you're doing is hooking to the battery, positive or negative, or to a breakout box. Simple. Any lab scope, I'm going to show you a whole bunch of pictures from different lab scopes. Any lab scope can do this on any car. We don't need the factory tool, and it's going to take you a few minutes to do. Seriously. Now, you see what I did on the bottom? I superimposed the bad one I had versus the good one. The peaks and valleys have to be the same height. They have to be the same width. You see the difference in the width here? I took a spark plug out to show you that one. So I did. And this is what you need to do so you can build confidence. When I do to guys sometimes at some of these trade schools, I don't want to mention names because I'm on tape, but when I'm teaching teachers at these other schools, and some of them have engines on a stand where you can take a valve cover off, have adjustable valves, because some guys go, oh yeah, well if you take a plug out, of course it's easy to find. Well, how about if you loosen a valve up? Any mechanical problem will show up with relative compression. Okay? So you need to invest a little time in it when it's slow. Pull your car in. See what happens if you loosen the plug up, losing some compression. Be careful. You don't want one flying out at you. Or take the plug out completely. It's not going to work. You're not going to get a failure with disabling fuel or disabling ignition. That's not mechanical. You got to do something mechanical. Does that make sense? So every once in a while, someone will go, oh, I disconnected my coil, and I didn't see any difference. I didn't tell you to disconnect the coil. I said make a mechanical problem. Okay? Questions?
What test is that? What are you monitoring there?
Right here, I am monitoring. This is something that you did with a big box scope years back. You know, every time it goes around the armature, the
Right.
piston's going up and down. What you're doing is reading that. And if there's any difference in, as they used to say on the big box scope, current draw, because we can do,
Cranking?
this is cranking.
You're measuring cranking, alternating cranking?
Yes, off AC voltage. But you could do this with an amp clamp like you did on the big box scopes. I know, we used to do it all the time. And when you have any difference in a peak or valley, and you'll see other ones. This just happens to be a particular one here off a fluke. Here's Pico. Now, I also wanted to show you in doing this that you can take their pull-down menu, and you can do this on Bernie's as well, but if you do this, they tell you to hook up your amp clamp. If you knew nothing about it, hook your amp clamp, your big one, around one of the battery cables. And around one of the battery cables, if you have an amp clamp like this, you can't use the... Oh, I'm pushing buttons. Look at that. Getting ahead of myself. Whoa, okay, there we go. Let me get my hands out of there. Thank you. So if you have one of these, this is nice to go around the negative cable or the positive cable. You need a big one versus if you go around with one of these, the small amp clamps, this is more for fuel injectors and stuff. This is more for ignition coils, Evap solenoids. You can't get the jaws to close around most of the battery cables. And it's not going to give you the right reading. Now, these things are not expensive. They're $100. Okay? You can use this on any scope. You could put it on Snap-on and OTC. If you have B and C, you need to get a little adapter that you could buy at Sears or wherever. But guess what? You could do this test just like we did here and see number one, right here, 0 amps, you see the 50 amps? That's the solenoid clicking on to start to engage your starter. You see the current draw on this car? It's about 410 amps. Then it comes down. These are the humps that we're worried about for relative compression. All the peaks and valleys are even, aren't they? Now, the reason why you don't see the fuzziness, this is AC voltage. This is an amp clamp on DC. Could have done the same thing on the other scope. But how about if you don't own an amp clamp? Right? If you don't own an amp clamp, AC voltage is fine, and it's easy. Okay? So, this particular setup here with an amp clamp, this was called Intero. The same guys that made Simutech. This was a very, very good unit, and it gave you the ability to look at ignition, cut cylinders out, but also do relative compression, and gives you a nice bar graph. Okay? So a good unit. You don't see many of them around anymore. Here, when I was doing a live thing here, you can go on our TST website, go to the P0171, you'll see a few things that I did, including this. I'm using their amp clamp on my battery, and I'm using their lab scope. And you see the lab scope? That's all those little humps are telling me relative compression. Don't worry about a little anomaly of a little thing. What you're looking at is the peak's got to be good, no big spacing, and we got no mechanical problem. That make sense? So you could become an expert in no time. Has to look even. Snap-on. Okay? This is their latest lab scope scan tool, the Verus. Well, look at the humps. They're pretty much all the peaks are all about the same, right? The spacing's all the same. That's good. Here's bad. I could get a 5-year-old to diagnose this. Good. Bad. Right? Is that hard? It's not hard at all. Really not. So why aren't you doing this as part of your game plan? This is how you'll find a lot of misfires. Because mechanical is the stuff that's overlooked that's going to put egg on your face after you've thrown all the tune-up stuff at it. I mean, we see enough shops that do that all the time. Oh, yeah, and look, the law of average on most everything, right? Out of 20 cars that come in your shop, one may be a little bit of a ball buster, correct? Most of them are going to be stuff you already know inside out. But you don't want to make the mistake. That one freaking car can ruin your day or your week. You don't want that. Here's on the Bernie scope. So there, right there is the little solenoid. There's the peak going up. I have it going off the scale. It doesn't matter. Soon as we get down to normal, are all those humps good? Yeah. There's not a problem. Okay? Here's on a Genesis. And you notice where I'm hooked? I'm sitting in my vehicle. I have the breakout box hooked. I'm hooked to number 4 and number 16. Didn't even open the hood of the car. I hit clear flood. If the vehicle has clear flood, I crank it over. In less than 2 minutes, I can tell you my relative compression is good. There it is on the Modus as well. Same thing. I'm in the breakout box. That's real easy. You should all own one of these breakout boxes. There's a couple of different ones out there. This one's from Bernie. There's another one from AES Wave. There's another one from a company, Can Do. It's a nice new one. There's a few older style ones with no lights on them. But it gives you the great ability to check networking. Like if you come to the big event, you're going to see that these guys, Ken Zanders, who's doing that, you're going to see that Kenny is using a breakout box with his scope. Okay? Because he's going to get in there on the CAN line 6 and 14 and see what problems you have. Okay? Without this thing, what are you going to do? Put little pins in the diagnostic link connector and it's going to fall out and give you a problem? You need the right tools for the job, right? And you can use this every day in your shop. Okay? Because you can do this on every car. Any car that comes in with drivability, I got the guys doing this all the time. Because I don't want egg on my face. You got a mechanical problem, And why are you selling me all this other work? Not fixing my car. Okay? So, which brings us to, after you see that, well, maybe you'll get someone going. And I should go back here 1 second. This is unsynchronized. What do I mean by unsynchronized? I don't know what hole it is. But you know what? The people, is it going to make a difference if the guy has hole 6 that has burnt valves in it or a bad piston in hole 5? Is that going to make a difference? No. I still got to take the guy's car apart. I'm not going to, it's like when we go to buy shoes. I don't put one shoe and leave the old shoe on the other foot, correct? You can't do half-ass work nowadays. This is not like years ago, I'll try to get away with doing this or that. You got to do the job right. So if people want to know, well, what I need to do is I can't do it all from here. I would need the second channel to go to primary of cylinder number 1 to sync it. That becomes my trigger. You remember like the timing light? If you wanted to see 10 degrees before top dead center, you had to put the little magnet on number 1. Or the old days with the spring, right? Then touch it by accident and get zapped. Okay? So we have to put it on number 1. If I put it on number 3, I ain't getting it, right? Same thing. So you could do your firing order 1342, whatever the case may be. You would find out what cylinder it is. I find most people, as soon as they know they got a mechanical problem, yeah, leave it. They don't want to spend the money. Because when you start pricing the job out, let's face it, and I'm going to show you some good ones later, you're talking some heavy money on these vehicles. We could do this. A compression test would be your next step to confirm something. And these are easy things that you know already, so I'm not going to spend a lot of time on it. But some people take all the spark plugs out. That changes your cranking speed, doesn't it? And if we had a head gasket problem between cylinders, we're not going to find it. But yet, you look at most manuals, oh, take all the plugs out. Well, when you get burned a couple of times, over the years that happened to me, and I said, screw that noise, I'm taking one out at a time, because if there's a pressure difference between it, I'm going to be able to see it. The amount of bounces, the first one, you definitely want at least 50% of the total. Because remember, cranking compression is engine sealing. Did it seal or not? Like that BMW story I told you today, wasn't sealing. Putting that STP in there got it to seal again, okay? And that compression reading came right up. So how many bounces? 4 bounces would be good. Let that needle go 4 times. Some people crank, up. It stopped at whatever number. Don't do that. It's not the proper way to do a compression test. Now, if it fails here, and this is all labor intensive, right? Now you go into squirting oil in, like we did today. I use that same can. Okay, squirt oil in, and of course on BMWs you're going to need to put a vacuum hose because you got to get it all the way down in the hole. So you need to put something to the end of it. And now see if it comes up on a wet test. If it comes up on a wet test, now you know you got a ring or a taper problem, right? The cylinder is worn. Now, you could do something called running compression. We said cranking is for sealing. Does the engine seal properly? Running compression is for volumetric efficiency. Are we getting enough air in the motor, and are we removing enough exhaust? That is the whole objective with running compression. If you've ever seen any races or go around any pit crews, they always run running compression. They always want to see what they can get in, it's very important, and what they can get out, okay? And that's the whole idea with superchargers, turbochargers, get a lot in, and why we have big exhaust to get a lot out, correct? Cylinder leak down would be your next thing. If you did those tests and nothing came up, well, now you're spending more time. You got to put it on top dead center, right? You got to put, whether it's this style one or the old 1 gauge style one, don't matter. You got to put air in this damn thing. You could also do it with smoke. Okay, it just takes a lot longer with smoke. But you put air in and you hear it leaking out of the intake, you got an intake valve problem. You know that. How much is a customer going to spend? Now, nowadays on a car, it's not like the old days, everything open. You do this on a Mercedes or something, whoa, you're probably talking 3-4 hours. Okay, 3-4 hours minimal. Does the guy want to spend that much money when he has over 100K on his car with this problem? Most likely, in my opinion, they usually say no. And that's when you got to make a call of getting your diagnostic money and getting out. You need that eye to say, not for me, I'm not doing this. You know, I'm not going to do all this work, and the guy's going to go, you know what? I'm not going to pay you, right? And then you got that junk car sitting outside that you're going to have to argue with them to get the title for, and we know how that goes. We talked about the crank and vacuum. Vacuum gauge is still something that's good to use. You want somewhere about 16, 18 inches of vacuum. Some cars, depending where you get it, try to go to power booster. We want a nice steady vacuum. Anything that's low pressure, we could have leak in intake or late valve timing. Nothing different. High or advanced timing, right? In the old days when I used to go to National Speedway, you didn't need a timing light, right? You play with the distributor, watch the vacuum gauge, make sure it didn't ping too much, you'll be okay. And the fluttering needle. This is a good one. If you see the needle fluttering, you got a valve train problem that you need to address. You're not going to throw parts at this car. So these are simple things that you already knew, but just to remind you. Here's one I want to kind of just go over again, because if you're like me and this gauge, oh, this is not my snap-on one, is it? No. But I have another gauge besides this. I probably got about 3 of them. But my snap-on gauge came with directions. It told me at idle, it's okay to have 1.5 pounds of back pressure. I got it right in writing. There's no way in hell that you should have 1.5 pounds at idle. You hook up to as many cars as you want. A car that has a clear exhaust system and a clear cat is going to have nothing. Anything more than 0.5 pound at idle is an issue. Anything more than 1.5 pounds at 2,500 is an issue. And when I do a hands-on class, I take the welding gloves, and I like getting a 4-banger in, because if the system's really sealed and you take some good rags in the welding glove, you watch that gauge and put a scan tool on it too. Watch what happens to fuel trim and stuff when you have clogged exhaust. Everything starts changing. You're changing load on the motor, aren't you? And we've had some of them where the guy held the pipe so tight, the engine just died out. Can't get 5 pounds of crap out of a 1-pound bag, right? Or in this case, a 0-pound bag. You seal it up. That system needs to operate. So very, very important to make sure when you're doing back pressure testing, you do it right. And don't forget that manifolds could even clog up. I had one years back, I took the manifold off, it looked okay. Not until I looked up near the head, the port, it was all solidly clogged on one side with carbon. This thing couldn't get out of its own way. You know, years back it'd be kind of nothing to drop exhaust systems on cars. Nowadays, forget it. It's a nightmare to drop half of the stuff. You get one of those V8 Audis in, that's a nightmare. Tough. Using some high-tech stuff. Now this happens to be John Thompson stuff, no relation to Bernie. But you look at the ACE misfire detector, excuse me, and you could see red is an issue. Never mind looking at the graph, okay? All he's doing here is using a sync signal to see what cylinder's what, so he could tell you up top what the problem is. This is a little transducer that goes in the tailpipe. It's from First Look. He made the software. He uses a Pico labscope. You throw it in there, and I have it. It works, it works pretty damn good. 2 cylinders are becoming a problem. 3 are good, but 1's real bad. Okay? Nice and easy to sell some work. And some people that do this, they make money with it by putting it on every car. Here's another screen where he asks you a little more questions here. You know, what's the vacuum reading? Is it steady? Where's your fuel trim? What he's going to do with that information, excuse me, is take all that and it's going to tell you, based on what you put in, it's going to say that this is not a mechanical problem, but yet it's a misfire suspected. It seems like it's an ignition problem based on all the information that you filled in. So that's pretty neat, right? Okay? And it works quite well. And here's a problem with no problems. There's no inefficiency detected. All a matter of minutes to do. Now you get to the Bernie tool, and I think you have this one, right? Now you get to Bernie's tool, and you could see in colors that you got problems, you got misfires, severe misfires going on here. The other nice thing you can do, that some people have gone out of their way to put it into paint and put drawing things on it. Bernie has the patent on this whole thing, and basically everything is pressure up top with power, exhaust, intake, and compression, and the bottom, everything is vacuum. Now this becomes a real ass-kicking thing when you want to see that timing chain or a belt or a gear or something slipped. This saves you hours of work, but that doesn't mean you can't charge for it, right? People have to pay for your technology. It's like going in for an MRI, right? You're going to pay big bucks, okay? You probably already knew that you had a particular problem. They're just confirming it for you for 2,000 plus bucks, okay? So, same thing here. You're going to confirm a problem. And if you look at some of Bernie's stuff here, if you buy his stuff, he gives you little tutorials. You may have even remembered years ago we had Bernie come out and do a whole class on this. Probably above most people's head at the time. But this stuff could really save you time if you go over it carefully and use it step by step. A lot of times when you get his DVD or something, you play it over and over, or you look at it, or you practice on a car like I'm going to show you what we did, then you go, my God, this thing is brilliant. And transducers now, everyone, Snap-on's selling them. They're all selling transducers. But Bernie gives you what's good or bad. When we did the webcast on this 2.5 liter car, you could see here we had a big problem. It was running rough. You look at the valve timing, it gives you a template. And right here it tells you the timing is advanced. So if you knew nothing, it's automatically, because you picked the vehicle, the engine size, everything, and says, hey, you got an intake, it's advanced. And if you look at this little thing here, which will blow up in a minute, this is key where it's supposed to be and where you're actually at. So after lining the belt up, they look the same. There's the bad, there's the good. So right here, that's advancing the timing. Now, since this is a non-crash motor, and again, I like playing with stuff, because how do you know the crap really works? Well, if you get a non-interference motor, and these things are real easy to change the timing thing, you loosen it up, you move the belt the way you want, it's a piece of cake, right? It's not a hard car to do. You could see, there's where it's supposed to be. I'm on top dead here. You can see we're off. So could you imagine saving time on that 5.4 liter with the two chains that comes in, or that Audi, or that Chrysler 2.7? Any of those motors, man, they'll eat your lunch. You rip this whole thing apart, the guy goes, "Whoa, I don't want to pay it. It's too much money." Because it didn't take you just an hour or two. It took you 6+ hours on some of these cars to get down to the nitty-gritty. And then to come find out, when you bill it out, we'll look up everything the guy wants. Goes, "Oh, I can't afford that. I can't do it." That's where you got to get your diagnostic money quick, get out and say, you may want to tow this thing home or whatever. You got some money. Then you come back and we can see if we can fix it. Now, excuse me. This one here, a Mazda RX-8. I had never worked on this. My son had gotten this into the shop a few years back. The guy he had working for him, a very capable mechanic, and they were using just the regular compression gauge. They weren't used to this. I was still playing with it. And the compression reading kind of looked good on there. It probably looked about 110 pounds or so on the regular gauge. So there's a front chamber and there's a rear chamber. Now you could tell there's a difference between these, right? It's not rocket science. Without the transducer, you couldn't tell the difference. When I screwed this transducer in to get these pictures, okay, now I remember the old Mazda RX-8 when they wouldn't start. Duh, that was a big problem with them, right? You always had to take the plugs out and squirt some oil in them to get the compression back. That was a normal thing. I had never worked on a Mazda RX-8. I was pretty much done at that point doing that. Okay? Now, unfortunately, I'm back doing it. But at any rate, looking at this thing, I said, well, it must have some other issue since it's not an oil type problem, it's not a sealing problem. It must be carbon buildup. So we run some carbon cleaning through it, and after running the carbon cleaning through, you could see that both of these were really pretty much the same. You don't have this stuff going on anymore. The carbon was a major problem. Now, I happen to know this guy, Ernie. He's the whole Eastern Seaboard rep for Mazda. He works out of Boston, but he covers the whole East Coast. I'd called him up at the time. In fact, I sent him this as well as Bernie. I sent him all these pictures that I had documented. And I said, hey, have you had problems with these? I never worked on. Oh, call me up anytime. Yeah, we got some problems with them. In fact, he says, give me the VIN number of the car. So I said to my son, Craig, you know, it's all right, give me the VIN number, I'll give it to Ernie. He wants it for some reason. So Craig gives it to me, I give it to him. He says, tell him he's going to be contacted by his closest dealer. We're going to give him a whole new engine. Now, meanwhile, this thing was running perfect. Okay? This guy owned a restaurant. He was happier than a pig, and you know what? He was giving us free dinners, the whole 9 yards. He was super happy because this car was like, whew, this was his baby. It was beautiful. They gave him a brand new motor. Okay, now there was no TSBs because I looked all that up. This was like one of those campaigns. If you complained to the dealer, they'd kind of hook you up. And he hooked me up. This guy got a brand new motor for nothing. So pretty neat. Any questions so far? So carbon cleaning, believe it or not, decarbonization really helps in a lot of different cases, especially in this particular setup. Now, if you've ever worked on these 3.2s, these things are a nightmare from hell. They're not an easy motor. And there's a couple of things we can do here. We have running vacuum problem. First of all, this is sinking number 1 cylinder on primary ignition. Look at the vacuum on a transducer. What I have here is I have a vacuum hose on a transducer connected to a transducer to the labscope. And I'm just hooked to the manifold. Well, you see all this jaggy junk? Right away, I know I got a problem. That vacuum should be steady. Taking it apart, all these oil seals always leak, okay? And the problem on this guy's motor, he had a broken keyway in there. It was giving a little shifting back and forth. And by the way, I'm surprised he didn't bend valves up. This is a crash motor. There was just enough on that keyway, I guess, to just keep it a little bit more. If it would have just deteriorated, he would have been buying a whole new motor. Okay, put it all back together, bingo, here's after. You see how nice and straight that line is? So that's how you play the comparison game. And if you could do this on a motor that you have, you know, a car around your shop that has an easy belt that you can jerk with or an easy plug to get out, to try some of these things, you're going to build yourself confidence. And again, you can make this by going to Radio Shack. Get the little project box if you don't own the transducers. That's 2 for $5. A little switch with the LEDs, another couple of dollars. A 9-volt to 5-volt converter, I think is like $7. And a battery, a 9-volt battery, and a good GM map sensor. Don't buy some cheap map sensor, because it'll make all the difference in a piece of vacuum hose. You could hook this up to every single car you work on, and you'll be picking problems up a lot easier. Again, it's all what you're used to doing, right? It's like when you do a brake job or you do whatever, you guys probably have everything set up the way you do it. You got your anti-seize, you got your special brake lube stuff, right? You got your brush to clean the caliper sliders off. You know what you're doing. Well, when you do drivability, you want to also know what you're going to do. You want to anticipate those steps that are needed. Now, let's talk about mechanical problems here. And if you're working on one of these Fords, well, the solenoid is an issue because of people not changing the oil or putting the proper oil in. In fact, Ford is very anal, and they want you to use a motorcraft filter. You should be aware that motorcraft filters are made by Fram, okay, and by Wix. They kind of split, I guess, how much they do. But you put a good filter in there versus there's a lot of these tire places that use these cheap, you know, they pay about 69 cents an oil filter made in China. You cut them open, there's Chinese newspaper in it. And I'm not kidding you. You need to go look at some of these things. They're garbage. Cut them open when you get one of these things come in, and they're using cheap oil and sometimes even wrong grade oil. Oil is not oil. You've heard a couple of different people we've had out go over the different specifications. Some of the companies have even been caught lying that the oil in their particular bottle, they may have used the Starburst or they may have used a word like Dexos approved, but you go to the bottle in the back where it has to have meets General Motors spec, yada, 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 number so-and-so, or Ford or whoever, it's not there. Because people can get away with stuff, right? And we see this all the time. You know, sue me later after I made $1 gazillion. That's how things work sometimes. So use a reputable company with oil, a reputable oil filter, you know, Mann, Malley, any of the OEs. Wix, of course, is a great filter. You know, be careful with cheap brands. So this guy here, he ruined the whole phaser setup. All the oil passages were clogged. The slack adjusters that are right here, these were worn to death because lubrication was not getting to them. So a lot of people, when they do these motors, they just want to replace the whole motor. Because in most of the times when you get a phaser go, and they're clogged up from oil problems, just like on this one, the whole oil pan had to come down, and when you're on a four-wheel drive, it's a real pain in the neck. The pan was loaded with junk, the screen was clogged, it needed a new oil pump, okay? And thank God there was no lower end problem. Because if you had a lower end problem, now you're cooked. And if you go on YouTube, you're gonna see a lot of people go, oh yeah, when you get those, just get a different motor. You know, get a crate motor and throw it in. This one here, off of Subaru, nice little story. I had a guy that had me go up to his shop to do a class, and he had two of the same scan tools, which is a no-no. He had two Snap-ons, a Solus and a Verus that he just bought. Same software on both of them. And of course, Subaru is a very tough car to actually get good data and good bidirectional control. There's like none of the companies want to do it. And the reason being, it may be a very big selling car here on the East Coast, like you see a lot of Subarus out there. But when I ask some of these companies, you know, how come you don't have more Subaru coverage? You go into some of these scan tools like Snap-on, as soon as you went in, it looked like it said you're in Subaru, they put you in generic. You're not getting any real data. So you could not actuate the phases on this thing, okay? So this guy was besides himself because it had an issue. It wasn't running good. I asked him if he had a power probe. First he looks at me, what's that? God's honest truth. So I explained to him what it is. Oh, I think we got one of them around here somewhere. And this is a beautiful 10-plus bay facility, air conditioned. I'm working here in the summer. Gorgeous place. Seems like money's no object to the guy, especially since he just bought a Solus and a Verus. Don't buy the same tools. It's okay to you buy those, but buy another brand because one guy will do something better than the other, right? At any rate, I said, well, we're going to have to manually test this now. Shut the car off. I'm going to unplug the wire, which is real easy to do on these. I unplug the wire, start it up, it's running really bad. Why? Because the phaser is not going in where it needs to be to adjust the valve timing, right? So we see one side is working. Now I go to the right side of the car. There's no difference. So we're able to get the solenoid off. It bolts up to the top, like right behind here. We unbolt it. You know the little screens in there? Both of the screens on both sides were clogged to death. We found out he put the wrong oil in the car. Wrong weight he's been doing. It's supposedly his customer's car. And the one on the right side's totally shot. The solenoid, he found the power probe finally, and I'm showing him how one side works, the other side don't. So you need a new solenoid, okay? So you gotta be careful. Use the right oil in the cars, make sure things work, understand how they work. Having information systems, like I'm a big proponent of all data. The reason why I love all data, they got description. Not that Mitchell's bad, but Mitchell, it seems like you gotta dig more. I go to all data, I get description. If I don't know something, I'm not real familiar with it, I read on it, and before I work on it, I go, oh, okay, this is how this thing operates. That helps you out. You know, as I said last night to guys, you could work on Toyota Evap. Well, Toyota Evap is not one system. They've used multiple systems over the years. And if you don't know what system you're working on and you don't do the read-up on it, you're not going to actually fix this vehicle because you're not going to know what solenoid's going to be on, right? Some of them use 3 solenoids. So it's not only the purge and the vent, now you have the other one that splits the canister. And they call them different names and they put them in different locations. You don't read up on the system, you're dead in the water. Okay? We'll look at this one that actually John Anello did. And he had a problem on this 5.4 with a 300, a P0011 and P0022 with camshaft problems here. Okay? Now this is another one that he got smart. He used the IDS and he sees that he got problems. And it looks like it's on one bank because 1, 2, 3, 4, and you may go, well, how come 3's not there? Well, it could not pick it up enough because it goes off, mechanical revolution, right? Versus an electronic type of grid that it's going to give you. But I can see at least I have 3 cylinders that are a major problem. And they're all on one side of the motor. Which, if you look at it, when he had the guy take this apart and he went back to take this picture, you look at where it's supposed to be and where this is, this thing was totally off. The other side, he's right on the money. Now, of course, when you're in there, you're going to do both change, you better do both phases. You're talking a serious job here. 2,500 probably on the low end. Because you need to put a lot of parts in this thing. And again, you're probably going to have to drop that oil pan. Because when these go and you hear the chains jumping or slapping around, the guy was using crappy oil, crappy filters. Let's speak about this particular car that came in, a 2002 Honda. This came in when my son was running the shop. And it had violent bucking and misfire problems. So here's where people don't think out of the box. And like I said, you really need to use the tools that God gave you. Your brain, your eyes, your ears, your nose, your hands. So when this thing came in with this violent bucking and you could have problems with the VTEC system, I said to Craig, since it has new oil in it and he didn't do it, I said, you didn't change your oil? He goes, no. I said, okay, it's got new oil in it. This guy probably changed his own oil. How do you know what weight it is? He goes, Dad, no way this guy changed his own oil. Now, he's not telling me this guy's 80 years old till he argues with me, for a while. I said, Craig, I'm telling you, the guy changed his own oil because I looked down, and you'll see the picture of the filter. He had a Purolator, one of these gold filters that you buy in a big box store. I said, this guy did his own oil. No, he's arguing with me. I said, just call the damn guy up, will you? Stop arguing with me. So he says, Dad, I'm telling you, you're wrong. I says, good, I'm wrong. Let's call the guy anyway. Call him up, and we said, did you change your oil? He goes, no. So right away, my son wants to jump on me. He said, no. He said, but my son-in-law. I said, aha. Now, be quiet, Craig. What did your son-in-law do? He changed the oil. I said, well, did you notice, like, after he changed your oil, did you start developing this problem? He goes, no, maybe. Because it only happened when it warmed up. Now, look at the specification. It wants 520. We called the son-in-law up. There's the filter that I seen. And I said to Craig, no professional shop did this. Because none of us would use this in a professional shop, right? This is your big box store. You buy this filter, yada, yada, yada. Okay? So the son-in-law put 1030 in it. Now, you know what happens on these VTECs. It happens on any variable valve timing. You start off at the lower weight. And by the way, 10W doesn't stand for weight, it stands for winter. Okay? So if you want to know a lot about oil, go to the Pennzoil website. And you can read everything, give you all the little things like the W is winter, not weight. And it went into a 30 weight. That's why when it was hot, this thing was bucking. The oil passages could not handle this. This wants a 520. And it's super important. Okay? And by the way, you get a lot of people on the 020s. They think that you could buy a non-020 synthetic oil, which is almost impossible to get. Okay? So anytime you get these people come in with new Hondas, they're mostly 020, you got to tell them, we use the Ademsu, which is the original oil, and we tell them, look, Sorry, it's only synthetic. You buy it, I'll pay you the difference, okay? Because I can't find a non-synthetic 020. Make sure the right oil is used, and that was the fix for this particular thing. Now, if you don't know, and it always gets back to the basics, right? That's a basic thing, but it was a misfire that you could have been hunting, throwing different parts at this car. Oh, it needs this, it needs that. I got to change the VTEC system on it. No, you don't. You got to look at the basic stuff. How does the system operate? And you can read this again on all data. Now, if you happen to be like New York City and you have this machine will tell you what viscosity the oil is, what's breaking down, where the problem is. In fact, when my son was buying all different oils, I went down and used the machine to test it to see which oil is better than the other. It's pretty neat. But you take oil samples, New York City has saved money changing oil and keeping a greener footprint by extending the oil they leave in the car. Okay, they buy good oil, they only use synthetic in all their vehicles, and the fleet has saved a lot of money because they'll look at it at 5,000, at 7,000 miles and go, still good, still coming up with the reading. Once it starts dropping, drop it. So this machine is somewhere upwards of $75,000+, never mind the supplies, but it only does oil. And you probably remember, like a guy in the class said last night, he goes, I used to work on heavy equipment. Every service, we took samples of the hydraulic, the transmission, the engine, the coolant, it all went out to a lab. That's what they do. This is like a portable lab, okay? And by the way, when you have an engine claim, like you had this new Toyota you bought or GM, whatever, you sure as hell it's going out to a company for that. When I had Quake Estate years back, I go way back in the late 70s, Quake Estate would offer this service. If you had a problem or you wanted to see what was going wrong with an engine, they give you these little bottles and they give you this little cardboard box. You put it in, you sent it to the company. They give you a detailed report. You know, your main bearing is starting to wear. You go, how the hell are you going to know that? By different material. You know, your camshaft lobes are wearing. Like, come on. They know it. So it's really good to figure out and utilize a service like that. Oh, it's okay. To certain companies.
Yeah.
Okay. I haven't done that in years, but it's nice to know I know where the machine is. So I get to use it because I work for them. Now, using an ignition scope. I'm not a big proponent of secondary ignition, so I like primary ignition. Nice and easy to hook up to. And if you look at this right here is the spark line. That's the firing line in the background. We have a lot of milliseconds of time here, burn time, right? Very important. Then we got our ring in. Well, look at the bad one. We don't have all that burn time, do we? So you could see you have an indication that something's going wrong. And in this case, this is not a coil wire or ignition or fuel. It's that valve that we took out of the car, okay? Where we could back it up by looking at different things, just like these old patterns of the raster, right? I mean, the display pattern. Raster was the stacking of the patterns that we just seen like this above each other, but display, if these were normal at about, on an older car, about 10 thousandths, on a newer car, about 12 to 15 thousandths, okay? If these are higher, let's say at 20 thousandths, well, you may have a lean mixture or an open gap, right? Or a bad wire or a coil. It's a good, quick way to see what's going on, okay? So a lot of companies, even General Motors, went away from using scopes in their thing. I'm talking big box scopes, never mind lab scopes. The scan tool became God. Scan tool knows everything, right? In many cases, the scan tool is going to BS you and you're going to run into a problem. That's why I'm showing you these alternatives to looking and figuring out a misfire. Mechanical problems, you know, when we have burnt valves or we have bad guides or we have whatever, that test that we talked about earlier, doing a relative compression test, is going to reveal those problems, as it did on that same vehicle with the valve problem. You see this? This is AC voltage on a Modus. And if you look at the firing order, it was number 3 cylinder, and it repeats itself, okay? That's if you sync it. Not hard to do, either through the breakout box or go to the battery, positive and negative. You're done in minutes. Little code reader like this. This is a great tool. This Code Reader 6, I use this constantly. And by the way, it's updatable if you own one of them. There's a little mini USB that goes to regular USB. You go on their website, they'll give you the new downloads for nothing. And in this particular case, a misfire from ignition coil secondary circuit. A quick check, and now you could go back and check it with your ignition scope or that little coil unplug thing. Looking at primary ignition right here, you can go down into toolbox. You can see where there's power balance, relative compression, and other special tests that they have right in their scan tool. This particular car, a bad aftermarket cam sensor on a Ford. And a lot of times these little buttons come out, and you remember these even on the old Napsi motors, the Nissans with the stage things where they used to brake, the carbon buttons. You got to be careful what type of part you put in a car. And by the way, we just bought brand new Bosch coils for a BMW we were working on. Okay, the dealer, they're on back order, so we couldn't get them from the dealer. Bosch is a good name, right? Out of the 6 coils, 4 of them were no good. Brand new in the box, never touched. You can see the little powder that comes in. You put them in, they pop out. You put them in, they pop out. You put a plug in them, pops out. I'm like, check the other one, stays in, stays down. Well, I had to order a whole bunch. I probably got about 8 coils going back to Worldpac now because they're defective, okay? You had to buy extra ones to find good ones. So even a good name sometimes, depending on where they're making these things, you got to be very careful, very careful. In fact, Pierre had something on another thing with different rotors. We went through, I don't know, maybe ordering 8 rotors or 10 rotors for the rotors he needed for an Audi he was working on. Scary stuff. Looking at sync, cam sync. Is cam and crank synced? Super important. If it's not synced, misfire data could be wrong, correct? The car may not run right. You know, one of the things that is super important, how many of you guys do reprogramming? Because nowadays, like, you can't fix cars without programming it. I was just telling Rich, I had about 3 GMs in a row. The fix for these cars with a P0300 the idle would be erratic, the light would come on, you couldn't do anything. Shops put a new throttle body in, you can do a master relearn, some of it's from your scan tool, it relearns the APP, the whole bit. The light still comes on. The only fix was reprogramming it. So many times you can't fix a car unless you go in and program it. When you do a reprogramming on a GM, if it's an older model, newer ones don't have the cam crank sync on it. They kind of did away with that. It does it as you're driving down the road, sort of like some Fords and Chryslers, BMWs and other models. But remember the old one, you held it down, 50, 150 RPMs on a 6-0, boom, 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 and it cuts out. You're good? I just did one, okay? And guess what? If you don't do that, after you program it, this car is never going to be right. It's never going to recognize a misfire. You're never going to get all the monitors ready because criteria is to make sure that cam and crank were set. And they warn you when you're reprogramming, right at the end, they'll say, you need to perform a crank relearn. Stuff like this. Here's our crank sensor. There's our cam in the background. Now, synchronizing this, there was John Thompson, who we spoke about earlier, who has come out and made a good CD and a book, because sometimes you need a good reference. How do I know that's good or bad? Is it, you know, after that, is it 5 over? Is it 3 over? Is it supposed to be on? How do I know if it's good? We could look at IATN and hope that the guy at IATN is giving us the same exact car that I'm on, right? Bernie also had some of these. I don't know what I did with his, but he had something he was selling very similar, but it did a lot more cars. It did European cars and so on. And it saved me many a times, as well as it saved Anello, plenty of times being out there diagnosing cars and going, hell, is that thing off or is it on? Don't know. Okay, so I'll show you a few more, like this one. This is a double bump off a GM car. Okay, I could tell you that's number 1 cylinder right there, and this is when it's down, when the computer's pulling the DC signal. This is an AC signal, and we got to be right in the middle of it. If it's a little over one way, it's retarded. A little over the other way, it's advanced. Makes a big difference. But if I don't know that, I don't know what I don't know, and I'm going to have a problem with a misfire. This is off a Chrysler setup, off a Caravan. These are just cursor lines for measurements. I should have took them off, but that's the way the picture is, so don't worry about it. Here's our cam signal. Here's our 3 bumps on the crank signal. They got to line up in the middle, either on the high part or when it goes down on the low part. If it doesn't, then I'm off. You can't see that, but that's a reading on the labscope showing us cam and crank sync as well. Now, this one here I've showed you plenty of times, but I always like sticking this thing in because this is a major mistake that someone made. You could see that the guy has coils, injectors, flex plate, cut wires out on his car, wires underneath. So all these wires, these were all wires this guy cut. Okay? I don't know where my little blow-up doll is. Here it is. There's the little white doll. Okay, so if you look here at some of the stuff he did under the hood, he has wires coming up, all cut up. There's 74,000 miles on his car or so. 4-liter motor. You know, just, I don't know how you even cut all this stuff. It's kind of ridiculous, right? So when this guy brings this thing in, and back then I was doing a class for Snap-on, okay, look at the wires he cut out of the car. 3rd flex plate in the car, and by the way, remember those 4 little signals? There they are. There's 3 sets of them. What the hell is the chance of this guy put new computers in, new cam sensor, new crank sensor? When Snap-on asked me to speak to this guy, they said, do us a favor, he's a good customer, got a big shop, see if you can help him out. He has this Jeep he's working on. Okay, how hard is this going to be? So I'm speaking to him, and I said, well, what's the problem? He says, sometimes it's hard starting, or it misfires, or it won't start. So I said, well, hard starting, did you check the battery? New. How about the cables? New. Starter, new. This guy threw everything in new. So I'm going through a thing. I said, well, how about the timing? Timing's good. He almost bit my head off. Now here's where a scan tool could screw you. Now the Modus at the time, and still to this day, has cam and crank sync pit on it. Tells you it's synced. It's not synced. Non-existent. I unplugged the wires, took them right the hell off the cam and crank, still told me it was synced. Put an OTC on it, didn't give me cam and crank sync. I do work with OTC, so I called up Ed Lipscomb and I said, hey, I'm working on a car, there's no cam and crank sync. He goes, oh, that's a Jeep. Chrysler product. I go, how do you know that? What do you got, like eyes in the sky looking at what I'm working on? He said, no, we couldn't get the information from Chrysler, so it's not in there. The DRB3, which is the Chrysler tool at the time, course showed it, and I also had the Ease tool. Ease did it, so I called Galinsky up, the owner of Ease. I said, Stephen, how in the world did you get this thing to give cam and crank sync? It's like perfect. They were going to buy his company. Chrysler was going to be the factory scan tool. He had some deal going with them, so they gave him the information. He put it in his tool. I went out, and this is no lie, I charged this guy $300 because when you see what I seen right away is that cam and crank, wrong way. Cam and crank is not good. You see the 4, 4, and 4? Here's the cam signal. They're off, aren't they? When you look at the other side, they're right on the money. Low, 444, high, 444, low, 444. Simple, take a 13 millimeter wrench, the dummy distributor, I turned it, I watched the scope, lined right up. Simple, because I knew what this should look like. And this guy winded up putting not only all the stuff you see here, he took the 4-liter motor out and put another motor in. This lady had a $7,000 bill. And when I said to him, what are you going to do? You're not going to charge this lady. He said to me, very words, the money's better in my pocket than her pocket. And I said, boy, that's wrong. That's wrong. It's going to come back and bite him. Now, tomorrow night he may be in my class, so I got to be careful. He didn't come to classes for years, okay? Wouldn't come. Finally, he must have felt a certain amount of pain. He started showing up. And he kind of changed his attitude, which hopefully he realized if that's your mother, you wouldn't want to rip your mother off, right? That's how I always think of it. We make mistakes. Sometimes you got to eat it, right? You know, it's just the way it is. Now, look at this one, a misfire. Look at the corrosion on there. Okay? Now, you're going to get, and you know why? You see these little spots here? You see this rust? That's water. That's water torture. Okay? So you get some vehicles that have water problems. Oh, that must be BMWs and Volkswagens and Mercedes, right? Those are notorious. And, you know, all of those European cars love water going in. By the way, did you guys read the article I wrote on the Porsche with the brake pedal? And you can look back online at Motor Age. A Porsche comes in. The guy needs brakes. He's metal to metal. We order him all the right deal of stuff, bleed everything out. Pedal's great. The summer was pretty dry, right? A couple of months go by, we get some of that heavy rain. All of a sudden it started raining like mad. Calls me up, says, my brake pedal feels real weird. Something happened. I must need brakes again. I said, well, bring it in. We'll check it out. And he had to go for calipers, the whole 9 yards, right? Brings it in. Wow, the pedal feels kind of weird. Almost like the brakes are sticking, like you go to push the car, and it's not like we adjusted a rod on the power booster or anything, right? I'm looking around, so I open the hood, you know, take the cowl apart. I look down, there's frickin' water all the way up to the top, okay? The drain was totally clogged. I have a picture of this, and if you read the article, you'll see I opened it up, and I have a picture of the water coming the hell out of this thing. Opened the power booster up, I cut the power booster open, the water was to the top. When he pushed on the pedal, he was pushing water in past the seals into the master cylinder. Had to flush everything out. Yeah, water. And I said, that's why you need to make sure under the hoods of these cars, the drains all operate. And I'm going to show you another one that came in from Utah, okay? Another car with water problems. And here it is. This Ford came in, and, you know, people don't look at debris underneath the car. And this is some of it after my guy cleaned it out. He said, oh, you're ruining a Kodak moment. Take it easy. We got to get a picture on this thing. So you get all of this corrosion here, all of these leaves, and making a problem for water. Here's the misfire, and you really have to look at this carefully because this is all water right in there. You see all this wetness here? It looks damp. You see those drops? Those are all water drops. Those are all frickin' water drops. So they were complaining of misfires and stuff, and look in the computer. We had to blow all this stuff out, and you kind of see like little shiny spots like here. You see that? That's all water. And it's tough to get a real good clear picture because what's happening, there's water on metal and stuff, and it kind of reflects back. I must have took like 50 pictures, and in all honesty, that's about the best you can get. So blowing it all out, put Stabilant 22 in there, and you should all own Stabilant 22, right? Expensive stuff, okay? Just did a Dodge Nitro in 2012 where they told this guy he needed a control unit and a fan, and make a long story short, and just go, you know, I sold them a blower resistor, which usually goes on those things. That wasn't it. I said, you know, I'm showing these guys that work for me, you know, when you have a problem, always go to the component first. Unplug it so you have nothing to do with any computer. Take the power probe, know what side's power and ground. Check the load. If the load works and it's blowing, you're not buying a blower motor. It's good. Then we took the meter and you checked the controls to see if you're getting different voltages to command it on. It's all working. It was all corrosion. You know, we put some Stabilant 22. It's an enhancer, remember that. So we blew everything out, cleaned it all up with the enhancer, plugged it in, plugged it out a couple of times. No problem. All set. Okay? So you need Stabilant 22. It's expensive, but it works real well. So here, water in the connector, in the PCM, the whole bit. What we also did, you see all this wetness back here? and all the corrosion here. These people didn't clean this in God knows how long. So we put a plastic boot. I made like a tent over this because the water was coming down, going in, finding its way. You know, if you take this cover off here, there's all the wires. It was loading up in there and getting right through. Okay? So water problems are out there. Primary ignition. Real nice setup here. There's the spark line right there. There's the firing line. There's the coil oscillations. And from here to there is dwell. The amount of time the coil is saturated before we fire the coil. Now these are nice and easy to get. All you need to do is back probe something. You don't need to buy all these special testers, correct? So I'm a big primary fan. Different primary things on different scopes. When I was doing a class, we just looked at different comparisons, what looks better, what's easier to set up, whatever the case may be. We have primary here, okay, and on top we have current. As voltage goes down, oh, it's just like a starter motor. Amperage goes up. And by the way, most coils at least pull 6 amps. This will get us back to what I said a little earlier on about Noid lights or test lights on some of those things. Well, if you notice, I'm at 500 millivolts per division. I'm using the baby amp clamp there, the small jaw one, okay? Each one of these lines is 5 amps, so that's 5 amps, that'd be 10 amps, that's about 7, 8 amps right there, okay? Also, the current ramping going up and the duration of dwell time, very important. And you can compare from coil to coil to see if you got a bad coil. Very easy to do. Remember, when you're using that, you need to go around only one of the 2 wires. So if we're using this clamp, we're not going to do one of these and go around both wires. We're only going to go around one and make sure the jaw is closed. We should have zeroed it first. We should have made sure we had a good 9-volt battery in there because that's a big problem, okay? And you could easily get your reading and do a comparison from cylinder to cylinder, okay? You can use this particular tool here called the COP3. This COP3 is a neat setup. If you've been a member for a while, you probably remember a guy called Mac Vanderbrink. Mac Vanderbrink is the father of the Allen Smart Scope and the Bear machine. When he was out here, this guy can pick the pepper out of the fly do. He's like the Bernie Thompson of the ignition system. I mean, he can look at stuff and diagnose every little crazy thing. He's a self-taught engineer, smart dude. He's probably about 89 or so now. The guy's like, last time we had him out, he had to go to the hospital. We didn't think he was going to make all 4 of the locations. So I'm always afraid to get the guy out because he's brilliant. He's a smart guy. I haven't seen him in about 2-3 years now. But this tool, you hook this thing up. You can hook it up to your scope or use it on its own. The green light tells you getting power to the coil. The red light, as it flashes on and off, tells you got a crank signal coming in. You hit this little red button up top, I could cut each coil on plug out without doing any damage. I could also use this as a good little taser. I take this little piece off. You remember when you used to load the condensers up years back and throw them down your buddy's shirt? He'd be jumping around because you loaded it up? You do the same thing with this. And by the way, this didn't work too well, me trying to take this through airports. They thought it was some sort of detonator. So I had to show them, I go, read the paperwork. They go, how do we know the paperwork is real? I'm in the automotive business. Don't take this thing away. Now, this is a GM test. You're all familiar with these coils, right? Well, if you go to General Motors, they'll tell you take a test light, go from one terminal to the other terminal, crank it over, and if the light flashes, it's all good. Baloney. What did I just tell you? Coils are at least 6 amps. So what you need to do is load the circuit. I use my old headlight bulb that I learned from working with Ford. We did this for a short on a car. We used a headlight, back then the old 6014s. We used a 5052 flasher. We would take the blown fuse out. Now you're putting this in, right? You got a connection, and what's it doing? It's loading the circuit up, you're flashing it, you're not burning anything. I used to take my little Mac, remember those little inductive alternator testers? Yeah, remember that? Not the one you get in that little black box. The needle's doing this. You take it out. You're not even moving, and it's bouncing around, right? That other one was good. You start to see what a short is. If the needle's going like this, and then you get here and it stops, the short's right there. If the needle's bouncing this way, you go till it stops, it's there. Great test. It was one of the great things I learned that Ford. But I still use that. That's the same thing I use without the flasher in. I put those to the terminals. If the driver in that module could light up that light bulb that pulls about 6 amps, I got a good driver. That makes all the difference. Forget about Noid lights, forget about test lights. They mean nothing. And you'll see in a little bit when we talk about fuel injector current ramping that a Noid light is no good. I got a lot of them if you want to buy them off me. I got to get them out of my toolbox. They're doing nothing. I'll sell them cheap, okay? We had this Chevy Express van come in, 3 DTCs. And the DTCs are a throttle position sensor circuit low. Okay, circuit low meaning, what do you think? Probably short of the ground. Circuit high is an open. By the way, from the dealer, the only way to buy the TPMS sensor, the throttle position, is buying the whole throttle body. In fact, a couple of parts stores, the same thing. We called Napa. They had a regular TPMS. We stuck the thing in. We solved that problem. Okay? There was no wire shorted. It was shorted internally. Okay? The other one was an O2 sensor, bank 2, sensor 2. We fixed that. And it had a random misfire. Look at our fuel trim. Long-term fuel trim, 7. Long-term fuel trim, this thing plus 7, bless you. So when we got both banks that are adding a lot of fuel, and I kind of look, if I got a problem on a car, especially if it's a misfire, okay, I use 6 as a number. If I got no problems, I ain't going to worry about the number 6 for fuel trim, right? Whether it be negative or positive. In this case, it's command and fuel. Well, this guy hadn't changed his fuel filter in a long time, okay? So that can be an issue besides him needing plugs and everything. You can see what cylinders are banging out on this car. New plugs, TPMS, and an O2 sensor besides the fuel filter fixed this car, okay? Or this van, I should say. So you need to take the information at hand and start thinking about different things, right? Do different tests. This stuff is like a grab bag, and you can't remember everything. Some of you guys are writing some notes down, which is good. You're going to go out, and if you got a couple of things out of this, it's going to help you diagnose cars a hell of a lot easier. Practice. When you get these snow-ass days, there's nothing to do, practice. Look at this coil boot. You think this thing is causing a misfire? By the way, this also caused the P0420 on his car because this guy ran this Honda that long. Now, an easy thing to do with all these deep well plugs or coil-on plugs or boots, get yourself some tin foil. Wrap it in tin foil, throw it back in the hole. So save your hero sandwich or whatever you call them out here, wedges, whatever. Save the foil, wrap them, stick them back in the hole, and if you got a misfire, it's going to happen instantly. You don't have to go racing it up, driving down the block. It's going to happen instantly. You should also keep around a bottle that we'll talk about with some baking soda in it, okay? Because baking soda and water is a good conductor of electricity. Don't put salt because salt is corrosive, even though it's a good conductor. If you don't like the guy, well, don't do that anyway, okay? Now, these coil-on plugs, we just had a few of these Toyotas, low mileage, that I was talking about earlier. The back ones are all the coils are all covered. And we've had a few of them, but we did a relative compression test. We knew the guy didn't have a mechanical problem. So now you're selling him a plenum, and both of the people decided they wanted all 6 coils, which you're talking a lot of money. 6 plugs, 6 coils, plenum get labor. You're talking a hefty bill. But both of them were people in their 50s that figured, hey, I don't want to get stuck. I don't want any problems. I don't want to ruin my catalytic converter. So we did it. Not sure. Usually, I see a lot of these things over 100,000 miles. Not a problem. But I guess a few of them that are newer, like 2009s, few problems we've had. When you see that these epoxy coils or E-coils are surrounded by a metal bar, there's a couple of things you can do here. You know that tin foil? If you're a secondary guy that likes secondary ignition, You remember the old little clamp that goes around the coil wire? Right? The little clamp piece goes like this. You take the foil, you make sure it clips. You make like a little clip top with the tin foil. You put the tin foil right over the epoxy part. Do not touch the metal, and you will get an ignition signal. You remember like the old GM HEIs on top? Same principle. It was a piece of metal going over the top where the coil is, it's going to pick it up. Some guy said last night, take a crank sensor, because it's a magnet, and connect it to that, or put it to your lab scope. He said, and I haven't done this, but it makes sense to me. Magnetic pickup, right? And he said it picks it up, gives them a good signal. So I'm going to try that on a scope. You take the crank sensor, he said, there's enough broken ones around. Take an old crank sensor, put it next to the coil, don't touch any metal, and he said you get a good signal. John Grossman, right?
Yeah, I think it was John, yeah.
You get a boot like this, you got a problem. Now, a lot of times when you get a boot like this, well, we could have a loose plug or something, that compression's coming up, we could have oil going in the hole. People that don't change seals, this one had oil in there, was one of the problems. You see problems like this. Here's new coils in the back. You can see burn marks on this. Now, we looked at them, and when you see rainbow colors, it's not a flashback to Woodstock days, okay? The purple and the orange stuff is bad. If you don't believe me, lick your finger, touch the little areas when it's running, and you'll get electrified. You'll believe me. You get stuff like this, poor quality, where the screws backed right out. Now, some people, of course, don't tighten them all the way up, but when you get a quality rotor or something, it has little Loctite on the screws. These made in China pieces of crap do not. You can see the rotor even came and hit the side of the cap, putting a hole in it, okay? So you got to be very, very careful. And the car drove in. That's a scary part, okay? But this is what's out there. Here's that little tester. This thing kicks butt. Just used it today. You want to see if that BMW, the coils work, whatever. All you do is you can select regular ignition, coil on plug, whatever you want. It gives you burn time, KVs, everything. You hit the button, you put this thing near it, picks it right up. It's one of those quick, easy testers. There's somewhere, I think when we were selling them through TST, somewhere in about the 225 range. Great tool, worth every penny.
Who makes that?
GTE out of Canada, GTC, General Technology Corporation, they're out of Canada. There's the bottle. Now, if you're using a test light, that's my old snap-on test light that had to go back, by the way, because the little piece up top, the wire piece always got loose, and if you don't baseline your test light, meaning went to the battery, negative and positive, to see if it lit up, and had the defective one like me, when we're spraying the water, and we're thinking this is a ground, so when we're going over the wire, we have that nice water mist with the baking soda, but we have no ground. It's not going to do anything, correct? So we need to make sure it's right. If that don't work, we can use the screwdriver with a ground wire on it. In case your test light doesn't work, just keep your finger off the metal or it'll be electrifying again, right? So you don't want that. And if you're not aware, a good way to kill cylinders, and I remember when General Motors first was doing this, when I was working with them, they said take vacuum hose and take the boot off. You can see I have it in there, and either the test light or a ground wire or whatever. This is a way to do a cylinder balance test. Now, a lot of people do not believe that rubber, it's supposed to be an insulator, right? Well, it's not really an insulator depending on the type of rubber, the molecules, correct? Because if you go out to your car tomorrow and you go on your radiator hose and go to the battery, do a positive and negative, right? And then take the lead and go to the rubber and don't poke a hole through it like one guy did in the class that night at about 10:30. And I heard the other guy punched him. Thank God I had duct tape because the guy kept pressing and he put a hole right in his freaking radiator hose. Okay? And I don't know why he did it, but next thing I know, there was some fist flying. At any rate, you will see that rubber conducts electricity. How many guys have seen that ESD on some of the hoses you bought from Gates or whatever? Or if you worked on some police packages and stuff, they used pure silicone hoses, the blue hoses. This is because they did not want a problem with the radiator producing extra electricity, right? You know, one of the little tests, when a ground strap or something is broken, you take the test lead, you stick it in the antifreeze, right? Well, you can see, you'll pull up. This is a great test if you want to kill cylinders. Get some vacuum tube. And by the way, be careful. You notice I didn't do two here. These are too close. They will cross right across. They will jump. So I do one at a time to see, can I drop the RPM down on this piece of crap Subaru? Okay? It's a great little test. Great thing to do. We talked about stressing the coil out, going all the way to see if it works. These coil setups, a lot of problems on these, especially with wires that start breaking down with heat from the back. Okay? It's a good thing to go use that spray bottle there with a ground wire. Look at this, secondary ignition. This is using the little Bernie clip-ons to the coil. Here we got a secondary pattern, but look at the red one. We got one dead cylinder. Okay? Shouldn't have a straight line. We had a problem. Oil going down on this particular car, oil soaked. Okay? Gaskets bad, plugs totally shot. Of course, there's tons of issues on that particular car. And of course, you've seen these. Now, when you come across these, if you're taking anything out of a 4.6, 5.4, any of this type of setup, do a decarb first. Get the engine super hot. Super hot. Decarb it. The carbon buildup will break off these pieces here. You see the difference between this one and that one? One, no decarb, decarb. The other thing you may want to do is get a good socket down on it, tap it a little bit. You even can give it a little shot with an air gun. I got a little 3/8 air gun. It's better than the air ratchet. You can give it a little boop this way and do a little. Not that you're going to tighten up. Little boop the other way and go in there with a ratchet and usually it'll come out. Sometimes they break. The new OTC tool I have works probably the best, better than the old Thexton one. You can get all that crap out, including the porcelain, the whole bit. Okay? These are tough. Now, Champion makes a plug that's all one piece, they say. But Champion plugs in a Ford motor, they don't work too good. So you got to decide what you want to do. Motorcraft or Autolite, the same plug actually. You know, anti-seize them, be careful putting too much anti-seize. Too much anti-seize will cause a misfire. There are TSBs, so use it sparingly, use the gold stuff. Yes?
I had a truck like that, a shop called me that I give them a hand. They took the truck to the dealer to get the plugs out. It came back with a misfire. When I pulled the plugs out, it looked like somebody dipped them in anti-seize.
Yeah. See, that's the wrong thing.
And that was the dealer that did it.
Yeah, and by the way, Ford has a bulletin on that. You do not dip them in, you put a little strip on them, you take your finger and rub it around. Don't use the brush and glob it on, it's too much. Just the strip of the gold crap, wrap it around, get it in there, and always start plugs with either a rubber hose or an old spark plug boot. I just yelled at one of the guys today. He's using, I said, dude, you're in an aluminum head. You don't use an extension and a socket to put it in. I have all of these things that bend or whatever, but you can easily take an old spark plug boot, stick it on a screwdriver, a Phillips screwdriver, and you can turn it in or whatever the case may be. Multi-strike. Ford multi-strike. We got primary ignition in the back, 3 primaries, and 3 currents. So you're going to hear the actual plug is going to do 3 shots, only at idle. This is for emission purposes. So multi-strike was used by Ford. Off idle, it looks like a normal setup. Okay? So sometimes when these first came out, people say, oh my God, I had guys coming in, look at this, got a problem with this thing. We don't know what we don't know. This is why you need to read or look. We talked about that power balance test a little earlier. Easy to do. Now here's the difference with good coils, bad coils. Here's the original coil that came out of the car. Got burn marks on the side. Like I said, you ever see where there's the colors or it looks like dirt is almost stuck there? What's happening is not all the voltage is coming out of the top. It's shooting off the sides to ground, okay? That's where that spray bottle will make you a believer. If not, again, use your finger, and when your head hits the hood, you remember me, that I didn't lie to you, okay? The current ramping that we get off the coil is either one of the primary wires going to it. And look at the difference between the bad coil in height, also in current ramping. Look at the difference of the good coil. It's higher. When we look at the amperage, each one of these lines, I have my scope set to 200 millivolts. My clamp is 100 millivolts per division, which means 200, 2 amps, 4 amps, 6 amps, almost 8 amps versus a little over 6 amps. And look at the dwell time. And by the way, when we did this with a aftermarket brand coil, the car did not pass inspection. We had to get an OE coil, which is this one here in the background, to replace the aftermarket one. You know, we figured this is not an advanced vehicle, right? How bad could XYZ brand from the parts store be? And it's a name brand, I'm just not mentioning it. So be careful when you buy some of this stuff. Here we got multi-strike, and you can see the difference in the on time between them. And here's where the guys had shorted one of the coils out, and on a 104-pin computer, notice, and this is blown up so you can see the peaks, but you got no amperage and you have basically no dwell time. They burnt the driver out in the computer because one of the guys, by accident, he took that cop 3 and he had the ground wire and he hit ground and burnt it right out. Okay. Of course, the rent-a-car company was not happy with me, put me on a blacklist because I probably at that point had ruined at least 6 cars. Okay. And not personally me, the guys in my class. So after that, they gave me, and this car probably had a few thousand miles on it. They gave me a new car with about 100 miles on it, and they said, anything happens, we're charging your card. We don't care, okay? So I told everyone, it's off limits, keys stay in my pocket, no one's touching it. After that, I was only rented rent-a-wrecks, believe it or not. Hertz and all of them, they'd charge me for a new car, they'd get me a rent-a-wreck. This was in the state of Alaska. That's a hitching post, by the way. That car also froze up one night. I didn't think it was going to be that cold. I thought it was only going to be 10 below, went to 30 below. And of course, it didn't start, had to be towed to Fort Wainwright, the Army base, and defrost for a couple of days. And the heaters they use here are not heaters that you normally have like freeze-out plugs. They silicone heaters that go under the oil pan, around the battery, differential, transfer case, because it's so cold, you ain't moving these things, okay? You know, that's how cold it is. And I made a little diagnostic thing for them, and the reason why I bring this up is you can get, I took a piece of extension cord from Home Depot, I took the outside insulation off, so now you got your white, right, your black, and your green. Doesn't matter which one I go around and take the amp clamp. Under the hood of all of these cars is a 4-gang electrical box, just like you would have in your shop. You know, the 4 outlet plugs, and the one from the oil pan, the one from the battery, the one from the differential or the transfer case or transmission, they're plugged in there. So if you know what the total amperage draw is when you go around one of the wires, you know, let's say it's supposed to be 6 amps. Okay, I got 6 amps of draw, everything is good. If I only have 4 amps, now I got to do unplug one at a time. This one drops down, next one drops down. This one does nothing. You follow that down, it's the one that has a problem. So I made them a little quick diagnostic chart because up there, you need it. It's that cold. This one came in, we were doing a TST seminar up in Mayapack, and one of the guys, Paul Muller, comes in with this misfiring Jaguar. So he says, you know, bring out your Jaguar tool, and I go, okay, first let me look. Remember I told you brain your eyes? We go outside, he start laughing. Pop the hood up. It's hard to see in this picture, but I think you could tell how these look and this looks. That looks brighter. You know what this thing was doing? It was like taking a picture of you. It was flashing. Every time it was firing, it was flashing. I said, dude, you got a bad coil. He just bought it from XYZ foreign car company. Of course, I'm on tape, I'm not going to say the name. But you know what I'm talking about. He bought it from them. It was a name brand. It wasn't OES. Now, you got to be very careful. OE is original equipment supplier. Let's say Bosch. They may make the wiper blades for the car. They didn't make the coil. It may be Bayer. It may be some other company. As soon as he put the OE in one in the next day, his problem was gone. And it drove him crazy because here he thought, hey, I bought a good part. It's not a bad name, right? He bought a good part, but it didn't work. So always look at the easiest thing. See if there's something different. Match it up. There's that cop tester again we talked about before. Works real well by cutting cylinders out, or in this case, if we're not getting flashing, we got no crank signal. You may have power, but you got no crank. Let's talk about misfires with fuel delivery. Now, I happen to own all three of these testers. These things are about $1,200, $1,500 each. This is a very good tester, not made anymore, does pressure and volume at the same time. This is an okay tester that does pressure and volume, but I've had problems with the sight glass in here. They've messed up a few times, and last night I had a couple of guys in the class. They said, yeah, I bought that too, and I've had to change at least 3 or 4 of them. This one has the best connection kit. It's Mighty Vac, and it's also sold through Mac Tools. It's about $500, $600 from the dealer. It does pressure and volume, but not at the same time. Who cares? Once I see the pressure reading, I flip a dopey switch and it shows me the volume, I'm a happy camper. If you go to our TST website, you go to the YouTube channel, go to P0171 where I'm doing the Mac Tool one, you'll see me using that. Okay, you'll also see that current ramping, fuel pump ramping, the whole bit. Pierre picked himself one up on the internet, I think, right? Did you tell me?
It's Amazon.
Amazon.
Mighty Vac name on Amazon. I think it was like $400. Wasn't that much.
Great tool. By the way, if you want to get good at current ramping, which we're going on in a couple of seconds, how do you know the current ramping you're looking at is good or bad? You need to know what the volume of fuel is. You need at least a half a gallon a minute on a 6 or 8 cylinder car or a turbo 4. And a regular 4-banger maybe 4/10 of a gallon. But if you don't get at least 5/10 of a gallon or more on a 6 or 8 cylinder or a 4-banger turbo, you got problems. I don't give a crap what your pressure is. It's really volume that matters. And that's going to make the difference with you checking fuel pump amperage. So what do you think about this fuel pump? Looks good, and 6 amps is about normal for most cars. Now, if you're on a Vortex motor, you better throw that out. That's a 9 to 11 amp car. If you're on a Ford pickup, an F-150, 350 gasoline motor, you're going to be looking at about 11 to 13 amps. They use those gigantic pumps on there, okay? So you got to know what car you're working on. But when a new car comes in, I did many cars in the 90s and the early 2000s that I did a bunch of cars, hundreds of cars. And now there's a big difference. A car comes in, it's a new model. Well, I don't know what the amperage is supposed to be. So what I do to back it up is I take that fuel volume tester out, and even on systems that are returnless, because a lot of people go, well, how do you do returnless? You're going to have to look at the fuel pressure for what the returnless system should be. We'll take 50 pounds as an example. You're going to go on the Schrader valve on the rail. You're going to take the other hose, the return hose, put that to a suitable container, and I do this in the webcast, or what I do in real life, I connect an extension hose and I put it right back into the gas tank. I take the little crimping pliers, and since this is a rubber hose on the tool, I crimp it until I get 50 pounds what the manufacturer wants. So now I have the right pressure, right? And I better have the right volume. I better have my 5/10, half a gallon or more. That's the way to do it. So saving stuff, like on this wave file program from AES, you see the good one up top? Look at the bad one. And here's the difference to tell good from bad. You see these boxes? You don't want something deviating more than one box. Like this is up here, and this would be one box in the middle. Let's drop it a little below. That armature has a problem. If that was in an aircraft, guess what? You probably wouldn't want to fly. If I was flying a helicopter again, I wouldn't want my ass to go up there with that. I'm not going to trust that. This is a good way, excuse me, to diagnose vehicles. You can predict if you're having a problem coming on. It's a good way to sell service, preventative breakdown maintenance, okay? If your amp clamp breaks, this is DC amperage, okay? And this pump is 1, 2, 3, 4, 5, 6, 7, 8 amps. You got a little dip there, but it's not more than a box, right? So you look at the peaks, measure the peaks across. Highest peak is where you say the amperage is, and you want to be no more than a box away. Well, if the clamp breaks, I could take AC voltage and go across the negative and the positive of the fuel pump, and guess what? I can get myself a reading, not of amperage, but the signature of the pump to see if the armature is worn. Does that make sense? So I can't tell the amperage, but I can at least tell what? The signature, how good the pump is signature-wise. Does that make sense? So if you don't own an amp clamp, you can do that. Now, this was a Celica that came in, Toyota Celica, that had a no-start problem. And you can see it went all the way to ground. And you see all this fuzziness? That's after hitting the tank with a mallet. Okay? Give it a boom, boom, started to run. Okay? So that's a bad pump. This is also a bad pump. But this pump has another problem. Does anyone know what the other problem is, besides being a bad pump? AC voltage, gentlemen, rides on DC. Your amp clamp becomes like a big antenna, per se, correct? Just like the crank sensor on the coil, that the guy's saying he can pick up the voltage. Makes all sense. What's happening here is the diodes in the alternator were no good, and guess what? You're picking it up on your fuel pump. So we've seen a bunch of that. When you get good enough doing them, you can pick different problems up. So that's what all of that hash is in between. Besides being a bad pump, another bad pump. Okay? Just different. I got probably hundreds of pumps that I've saved over the years from WAV file programs. Another bad pump. It's the lady who ended up suing Volkswagen because they couldn't figure it out. Brought it to me. Well, you need a fuel pump. Not because I'm a rocket scientist, because it's not good and it's not that difficult to figure out that's not good. She wasn't getting the right fuel delivery. Here's a new car. What I do with the city on the police cars, we take new vehicles, and when they're brand new, you see that's 200 millivolts, so that's 2 amps, 4 amps, 6 amps, 8 amps, it's a 10 amp pump. Look how beautiful that is. It only has 10 miles on that car. Okay? Now, when you have the good reading when it's new, even with scan data, when you get a problem car and now all of a sudden you're at, let's say you're at 6 amps, well, you got a problem. We may have voltage drop, right? The corrosion that you guys see on some of the wire connectors, or the amperage is all of a sudden up high. The fuel filter could be clogged. You could have mechanical resistance. So once you know what something is good, you get good at utilizing this to see how you're going to detect the problem and how you're going to detect the misfire. Well, it's not rocket science here, and by the way, you cannot clean injectors by using different chemicals. Not even my favorite run right stuff. Doesn't matter what you put in. If the screens are clogged, the injector, that 1 to 2 micron screen, if you didn't wet the fuel filter and the paper ripped, because they find a lot of paper and debris up in those little screens, okay? If rust from a tank went up there and it started packing up in there, I don't care what you're putting through. I don't care if you have your Motovac running for days, you are not getting it out because you can't even get it out with a pick. It's that hard. The only way to do it is actually test them first, and you can see this one is obviously a major problem. These are all the same. Look at that one. Okay? You can see the difference here. You want to know why you got a lousy running motor? Now you got to pop the screens out. Since I have this thing, I throw the injectors in the ultrasonic cleaner. Hours later, you put them back in. If they're all even, they're good. Sometimes we've had to leave some in overnight. That's how bad. Adam Varney gave us some from some car, I forgot what it was, some old car where they couldn't find injectors. We probably left them in there like a day and a half, and they finally cleaned out. And when you look at the bottom of the ultrasonic thing, you see all these little pieces of debris that God knows if it's metal or whatever, who cares? There's a bunch of dirt, whatever came out, as long as the injectors work now. So that's the only real way to do it and test them is on an ultrasonic setup. Now, here's one big problem that's out there. And last night we had, if you guys have come to the big event, you've seen the guy from Wins, Will. He's always in the back, not Wins, BG, he'll kill me. BG, I get that on film correctly. And they're a good sponsor of ours. And cleaning, if you stay on top of direct injection, cleaning at normal intervals, about 5,000 miles or so, because as little as about 6, direct injection is starting to build a lot of gook up. And they even make a kit that has like these little plastic picks in there and little wood things to clean them out. Because when you look inside this motor, you can see these valves are caked. They're just caked up with crap. And this is a lot of intensive labor to rip everything apart on this car and then get it like this. You can see the insides are all nice and clean in comparison to the top. Dark hole versus a clean hole. You know, just look at the difference. And when you pull the stuff out, it's not that hard carbon stuff. It's like this gooky tar stuff in many cases. And be careful, don't go in with metal picks or anything, because these valves are not like years ago. You could easily scar them, bend them, ruin a seat. You got to go in with either some plastic or some woods type stuff and cleaner. Most of the time they recommend you get a funnel, you pour a little of the cleaner down in there, you take some wire ties in a bundle, like plastic wire ties. Some guys put them on a drill, you got to be careful, like make a little tent area, because when you're going around with the drill, the shit goes all over the place, okay? Or you take the wire ties and you're jamming them. You made like a little, you know, group of these things and you're jamming them down like this, helps break all the carbon out. I use the air vacuum, okay? I have two, I got a brand new one from Snap-on, I don't use that one, I'll use my old Mac one, and I'll suck the crap out, it makes a mess of the thing, but you're getting paid for this, right? And you get rid of all the old stuff that's there. Once it's nice and clean, go in, make sure you clean up any extra liquid. We don't want to hydrostatically lock anything. It's a good idea to always pull plugs out and make sure there's nothing in that cylinder. You know, maybe even crank it around and make sure there's nothing down there to have an issue. This particular car came in with a vehicle, came in with a P0300. We don't have any crazy fuel trim numbers anywhere. We do have all our monitors ready, which is important, but his misfire was from a bunch of carbon buildup. So even though someone sold him a tune-up, you know, he had a new cap, rotor, wires, PCV, plugs, the whole bit, he was getting a misfire code, no problem with his crank sensor or anything. His piston looked like the moon. And by the way, when you have something that has upwards of 70,000 miles on it, I don't care whose cleaner you're using, one can is not going to do it. Because one can will approximately last about 20 minutes or so. And last night we heard from the BG guy that he thinks, or their studies should say, they want you to run the car at pretty much at idle. I usually pick it up to somewhere about 900 RPMs to 1,000. He says it's better at idle because what happens when it's too high, you start fluffing it around like this and you're not getting the cleaning actually going in. You're blowing it out too much. So, whatever. He's smarter than I am at that. You know, but I've had good luck doing that. You know, it resolved the problem on this guy's car, also on his wife's Subaru. You know, cleanings I've told you before in other classes, like on P0420, it resolved her problem with the P0420 without replacing the catalytic converter. Cleaning it up and making sure, obviously, she had no other issues. Carbon is a problem. This Jeep Liberty came in from a student with the problem, and sometimes some knowledge is dangerous. This guy looked at mode 6. He had some problems here. The shop checked that. They replaced injectors from Lambdas, oxygen sensors, cam and crank sensor, plugs. They did, new computer on this thing, throttle body. And the transmission, they were ready to sell her a transmission. Obviously, excuse me, when a vehicle is not running right because it's misfiring, transmission ain't going to shift right. It's not rocket science, right? It's something that you should know. Well, lucky his boss, and he's the lead tech at this place, his boss said, you know what? Let's get this thing down to G. Let him check it out. Let him charge us. The lady's starting to get cranky at this point. And they threw all the stuff at it. They weren't resolving the problem. I look at it, and I'm getting misfires, okay? Look at the fuel trim. It's requesting fuel, okay? I put the misfire thing in. He's misfiring. Now remember, enabling criteria, you may not get a misfire code coming into the OBD2 setup, correct? But I know I'm misfiring, and I know I got high fuel trim. It's a JTEC. It tells me that this particular car should have 49.2 plus or minus 2 pounds of pressure. All right, so basically 50 pounds. Then it also tells me that if fuel pressure is below 55 pounds, the fuel pump module does not need replacing. If it's under 55, if it's above, there's a problem with the fuel pump module. You need to replace it, right from Chrysler, okay? So now, fuel pump current ramping, and by Delphi, they say an increase of 1 amp for every 10 pounds of fuel pressure. Okay, sometimes that doesn't hold true. Because on a vortex system, it's 60 pounds. That means it would only be 6 amps. Well, those pumps pull 9 to 11 amps. So it's not always accurate. And by the way, they're the guys who built that pump. But they're not the ones who put the regulator in, because what they did by mechanical regulation, they made the amperage go higher. That was General Motors. Delphi designed the pump. They didn't do the other part of it. So is that good or bad? And here's just some information if you want to calculate 60,000 milliseconds or in a second if you want to calculate speed. I say don't worry about that baloney. I just put it there for the people who kind of want to know. For the simple reason, most fuel pumps are variable speed fuel pumps nowadays, right? So they're going to look at VSS, they're going to look at Prindle, they're going to look at load. It's not going to really matter much. Now, on this, fuel pressure 48 pounds. We're in the spec. Excuse me, plus or minus 2, correct? We're in the spec. How about the volume? The volume, the little ball, is down here at about 0.2 of a gallon. That's no good, right? You know it got to be 0.5. Pressure afterwards, 48 pounds. The volume, about 0.6 of a gallon. Now the car is fixed, okay? So if you looked at what this guy looked at, and I want you to look at it carefully. There's the bad pump, there's the good pump. But look very, very carefully. The amperage is not that far off. We're about 6.25 amps. Okay, the pump looks pretty damn good. Look at a new pump with 6.75 amps, just under 7 amps. Even if I looked at this without a volume test, I'd say it's a good pump. That's why you can't always go by that. Okay? So when in doubt, he didn't do all his homework. He didn't look at fuel trim. Why am I commanding 9? Remember I told you it's 6. If there's a problem, I start looking. You got misfires going on, dude. And by the way, she didn't need a transmission. Transmission was fine. So the owner was happy. Okay, another one. This came in, a 300, a 305, 306, 307. 2010 Ford, he doesn't do much to this thing. So there's all our codes. Freeze frame was at a 305. We have fuel trim, bank 2, left bank, negative 10.9. Fuel trim, bank 1, a positive 9. One side's taken away, one side's put in. Keep that in mind. One side's taken away, one side's put in. Monitors not complete, 4 of them. Now you got to go, oh boy, I feel it right here. You fix one thing, more stuff is going to come back, right? Relative compression's good. I rule out an engine problem. Right away, engine problem, gone. Power balance, oh my God, this thing is all over the place. I have issues, and it's on 6, it's on 8. 7 doesn't show you, but we got some issues going on there on that bank. 6 and 8. New coils, new plugs, it ran better, but it still wasn't running good enough. Fuel volume and pressure, they're good. I'm about 7/10 of a gallon. Okay, so I'm good, pressure's right on what they recommended. The intake runners, the motor. Now, by the way, I'm going to give you a real tidbit here. Ford dealers are going to try to sell you the whole manifold. You could buy just the motor. If you have the factory tool, or I think Launch did it, Autel did not, it allowed you to bidirectionally control the motor to see if it goes back and forth. Problem was the motor wasn't always working right. So these little doors flaps weren't working good. When I took this off, take the linkage off, make sure the flaps do open and close right. Sometimes they can be the problem. In this case, I waited a couple of days and I was able to get a motor. I put the motor in. So now you think you're all solved. Not yet. What do we see with fuel trim? This is bank 1. This had 9 plus, well, look at this. We're 15, 16, 17, lightly into it, start getting into it, 27 and 30. This truck was falling on its face, couldn't get out of its own way. Look at this, 23 at idle, all of a sudden drops down to negative numbers, minus 23, minus 25. What do you think? Look at volumetric efficiency, your next step. Volumetric efficiency, if you don't own this tool, you do have a generic scan tool with calculated load, right? You want at least 90% when you got this thing pedaled to the metal. Well, we're not getting this. You see, and you see all the hash in it? That's like back pressure, right? You know what the back pressure is? My trusty Snap-on good gauge. Thing's older than some of you guys in here. That's about 4 pounds of back pressure on the left side of the vehicle. Catalytic converter was toast.
Because of the misfires.
Because of the misfires. Okay? And the runner not working right. Can't get enough air in there. Misfire, that thing was loaded. And these cats are not cheap. The other side, 0 pounds of pressure. Okay? That fixed the car. Look at the difference. Look at the difference. I mean, it'll take a little while for that to get back, but look at the difference on it. Okay? And look at this. The red is right behind it. No fuzzy-wuzzy junk, right? We're banging right up where we should be, right on the red, versus, keep that in mind, look back here. Look at the difference. See the reds in the background and you get all the fuzzies on the yellow? The red is where it's supposed to be. The yellow is actual. So you couldn't meet the top and you were breaking up versus you're just mimicking those 2 lines. You're right on it. It's perfect. Vehicle now fixed and returned. Okay? Just different other misfire tests that we spoke about earlier. Real quick things to throw in the tailpipe. Misfire relative compression by the tailpipe. This is another thing he has in there. You can do by pulses if the relative compression is good or bad. In this case, it said it was a problem on a car. Another misfire, you see that thing misfiring? Intentional misfire I made. It picked it up and it told me what cylinder. He was looking off syncing it and finding what cylinder was the problem. So just different things where it can show you what's going on by a transducer in the tailpipe and software. Same with the Bernie stuff. All those cylinders are good, boom. Number 3 is a problem. Great stuff. You got to use it. Okay? You have to be able to use it. No problems. Now, a lot of times this gets people confused. Well, how come over here that's bad, but this is not bad? He's doing all these calculations. I told Bernie sometimes it's better to cover that. In fact, when he made a tool for a specific company, they took all that out of it and he just gave you good, bad indications. Because some people read too much into this. He's checking it multiple firings and multiple firings where sometimes an internal combustion engine is not perfect, is it? Otherwise it would burn every drop of fuel. We wouldn't need a catalytic converter. So you are going to have some natural misfires, correct? So you're going to see some anomalies. The bottom line, he counts them up, and if they're good, they're good. Crank and vacuum, okay? So if you look at primary, I'm cranking it over, but look at this crank and vacuum. Okay? Is that good or bad? Here's crank and vacuum, no problem. This is with a plug out. This is something you can try. Nice and easy. All I did, connect to the power booster hose with the vacuum transducer that you can build. You guys can email me, I'll send you a picture of it, okay? All I'm doing is connecting my scope to the black lead of the pressure transducer, not the ground on the car. Remember, we got to be in the circuit, right? Where the 9-volt battery is. The red lead, you know the middle wire that you used to test, right? There's 3 wires. One's a 5-volt reference, one's a ground, and the middle wire. The middle wire is where the red lead or yellow lead of your scope, whatever, goes right there. You're done. Set your scope up and you got a reading. And you can use it on anyone's scope. And you're going to pick some problems up and see why maybe carbon buildup sometimes causes it. And it's a good reading, by the way, to have a good way to invest into a video scope. Look down on some of these things, and it's a good way to sell service. People need cleaning. Okay? And people that don't stay up putting some can of K44 or Techron or Run Right or something in their gas tank on a regular basis, they're going to wind up with problems. And it's not going to be pretty. Okay? And there's crank and vacuum, nice, no problem. Multiple, here's our last one here on a Lincoln. Multiple misfire. Well, how many of you guys have come across those hoses in the back? Buried, right? They're really pains in the neck. You need to look for these things. Misfires can be from other things, okay, besides plugs and stuff, right? And in this case, the hose has been so deteriorated, so soft, that you're running into problems. And of course, you got to rip everything apart on these nightmare things, and it needed new coils. I want to thank you guys for coming out tonight. Drive safely.